ما
Sir, good morning.
Good morning, madam. Hello, everyone. Very good morning. Welcome. Happy to see you all again.
Sir, I find little disturbance in your audio. It's cracking.
Oh, really?
Yeah. Sir, good morning. Students, how about you? Can you hear the sir's voice clearly?
Yes, ma'am.
Yes, ma'am.
Yes.
So my voice is properly audible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Then it is all right.
Okay, shall I start, sir?
Yeah, sure, madam. We can start. And some students are joining. So all the participants who are here, please introduce your name in the chat box. Meanwhile, before madam starts, just type your name in the chat box.
Lokesh Soy Deepak, from which department? You have to mention that too also. Mechanical.
Okay. So all of you are second year students, right?
Yes, sir.
Oh, okay. Thank you.
Third year, sir.
சொல்லுங்க ஆதர்ஷ் ஏதோ சொன்னீங்க ஹலோ ஆதர்ஷ்
Third year.
Oh, third year. Okay. So some third year students are also here. Very good.
Yes, sir.
So are you all excited to learn Lean Six Sigma?
Yes, sir.
Yes. Yes, sir.
Very good. Very good. Yes, madam. Then we can start. Priya, madam, we can start.
Yes. I will share my screen.
Yeah, please.
Okay, good morning, one and all present here. This is Hamsa Priya from Msme-Tdc Chennai Team Campus to Corporate Program. I welcome all the participants for the Certified Lean Six Sigma Yellow Belt Training Program. And I would like to thank MSME before that for this wonderful opportunity. And also I welcome our lead facilitator, Dr. Gopal Shivakumar.
Thank you.
Here we have some of the virtual classroom etiquettes. Now we are in a virtual world, so you all are aware of this virtual classroom etiquettes. Anyhow, I will explain you how to behave in this 3 days of our training program. Participants, you are requested to turn on your camera, so it will be very useful as to feel connect with the facilitators. And feel free to unmute yourself before speaking. If you want to convey anything to our facilitator or you want to clarify any of your doubts, please use the unmute button. That one you can find it in the bottom of the screen before you are talking. And feel free to use the chat box. You can use the chat box also, and it will be answered at the end of each and every session. Whenever you have the doubt, kindly use the raise hand button. That too also you can find it at the bottom of the screen. And feel free to use all these above options to stay connected with our facilitators and enjoy your happy way of learning. Yeah, this is our short introduction about our facilitator. This is Dr. Gopal Shivakumar. He is our lead facilitator. And we have one more co-facilitator, Dr. S. Ravi Kumar. Let's see the short intro about Professor Dr. Gopal Shivakumar. Sir is a PhD and Lean Six Sigma Master Black Belt holder, and Sir is also an author, trainer, and principal consultant. Dr. Gopal is an expertise in SPC, design of experiments, MSA, hypothesis testing, regression, and 5S. Dr. Gopal has 18 plus years, 6,600 hours of training experience, and he has also authored 7 books in mechanical engineering and also in mathematics. Dr. Gopal has demonstrated highly successful DMAC projects for his clients. Welcome, sir.
Thank you, madam.
Here, let's see about our co-facilitator, Dr. S. Ravikumar. He is a PhD and a Lean Six Sigma Black Belt holder. He is also a trainer and consultant in Lean Six Sigma. Dr. S. Ravikumar has 18 plus years of experience in industrial research and teaching. He is also a consultant in Lean Six Sigma and also a expertise in fault diagnosis using machine learning. Dr. Ravi, as a project manager at thermal power plant, successfully completed bulk material handling projects, and he has published more than 10 technical articles in international journals. Here we have the details about our session recordings. All your session recordings, that is 3 days of our training programs, are recording parallelly. Each will be uploaded in the app named Six Sigma with the GSK. This is the app link. Everything will be shared in our WhatsApp group also later on. Please, once it was shared, it will be shared. Participants, you are requested to upload or install the app, and you can get the access to view the videos of 3 days of this training session. And we have the another option also. Now our training is on live stream in YouTube. Please subscribe the channel. I have given a link in WhatsApp group. Subscribe it, and you can see it in the YouTube also. And if you have those who are in YouTube channel, if you have any queries, kindly drop out your comments and drop out your queries in the chat box. It will be answerable at the end of each and every session. Here we have the participants introduction. Participants, let me know your name and objective of attending this training program. It will be helpful for us to serve you better. Thank you one and all for this happy way of learning system. And I am handovering this session to Dr. Gopal. Thank you all.
Yeah, thank you, madam. You mentioned something about student introduction. Do you want to have it now, or you want me to start?
It's 9:37, sir. At least some of the students can introduce. It will be useful for us. What they are thinking and what is the objective of attending this training program. It will be useful for us to serve them better.
Very good. Yeah. So, few students, would you like, you can introduce. Particularly, you can let us know some of your expectations. Then I will start. So now it is 9:38, maybe 2-3 minutes. Students, anybody would like to speak?
Students, please come forward and specify your objective of attending this training program. For each and everything what we are doing, we have some intention and we have some objective. So let us know that it will be helpful for us to satisfy in this training program. Please let us know why you have joined this training program. At least 1 or 2 can address this. Here we have 99 students.
Attendance, that's all.
Yeah. No, others are watching in YouTube, sir.
Wow, great. So I'll be starting after 1 or 2 of the participants introduce, right? I'm just waiting for your introduction.
No one is there out of 99. Okay, sir, let us not waste our time. You can start the program.
All right. Thank you very much for the wonderful introduction and the welcome. So we'll proceed. I think the participants are introducing in the chat box. There are many messages keeps on coming.
Yes.
And somebody says you want to gain some skills. Good. So let me share the screen and then take all of you through the program. Just few moments, please. Share again. Confirmation again. Is my screen visible to all the participants and my voice is properly audible?
Yes, sir.
Yes, sir.
Oh, great. So, dear students.
Students, before that, why not be in video?
Yeah.
You can open. No, it's looking a blank screen. It will be fine for us.
Some of you can prefer to come on video, though it is not compulsory. Right? You can come on video and make the program, a little lively, so that you can see your face and then talk to you. That will be, a much better environment. Thank you, Saravana Prasad, for immediately accepting the request. And all others also you can prefer to do that. Okay, once again, welcome all of you for the Certified Lean Six Sigma Yellow Belt Training Program. So, before entering into the topic, so who is an yellow belt? So, what is called as an yellow belt? Generally, professionals, whether it is an engineer or a doctor or a lawyer, whoever, they grow in their career. How do they grow in the career? They grow in their career by helping their clients. So, doctor helps patients, lawyer helps his clients, an engineer like you, all of you, you will be helping your clients. Your clients are predominantly industries because you would like to work for industries, right? So your ability to help your clients defines your belt level. So the belt level is actually based on your ability to help your clients. Say for example, let us take in a hospital scenario. In a hospital, who is an yellow belt? In hospital, overall will be there. Chief doctors will be there. And then nurses will be there, isn't it? So many people will be there. So, the yellow belts can be equated to the nurses in the hospital. Can one of you tell me what are the duties of a nurse? Can one of you, can you speak about the duties of a nurse? What the nurse is supposed to do? Come on, you can be interactive also. I have no issues, you talking in between. In fact, that will be good.
They help the patient.
They help the patient directly or they help them according to the doctor's instruction?
According to the doctor's instruction.
Very good, beautiful, right? The nurses help the patients according to the doctor's instruction. Similarly, in an industrial environment, any project a professional is handling, there will be people who will work on according to the instructions given by the project leaders, right? So if we equate nurses to the yellow belts in hospital, then who will be green belt, right? Green belts are nothing but the doctors who directly deal with the clients, who directly deal with the patients, who really understand the pain of the customer, pain of the patients, and then decides how to give the treatment, right? such responsibility is called as a green belt. All of you understand the difference between an yellow belt and a green belt?
Yes, sir.
Beautiful, right? And then in hospital always, there will be chief doctors, experienced people, specialists, isn't it? So they are capable of handling complex cases. Am I correct? They are capable of handling complex cases. Even these doctors will be guided by the chief doctors. Am I correct or not?
Correct, sir.
Yes or no, right? Frequently. So these chief doctors will help these doctors on how to handle the cases and how to handle complex cases and how to in fact give treatment and all those things. A similar structure, if you visualize or if you imagine in an industrial environment, that is nothing but the yellow belt, green belt, and the black belt. Am I right? So the nurse role in an industrial environment will be played by a set of executives or set of professionals who are called project assistants. The doctor's role, who directly deal with the customers, problem, right? Client's problem, the organization's problem. They are called project leaders. Since there are different levels of projects exist, we need guidance for we need to provide guidance to these project leaders also. And sometimes whatever projects these project leaders are not capable of handling it, that will be handled by higher level professionals called project guides. And that's what we are going to call them as black belts, right? So understanding these terminology and acquiring skills similar to these professionals will really make you work according to your client's requirement. If you work according to your client's requirement, if you ensure your client's satisfaction, you will get paid for it, isn't it? And you can be paid a higher compensation if you really acquire these kind of skill set. And predominantly your clients will be industries, right? It could be manufacturing industry, it could be a service industry, be it whatever. So by the way, madam has already introduced me. So my name is Dr. Gopal Sivakumar, right? Besides holding a doctorate degree in mechanical engineering, I'm also a certified Six Sigma Master Black Belt, right? I have done several projects in Six Sigma and I have helped several people become low belt, green belt, black belt, and even master black belt levels, right? So this talks about my experience. All right, coming to the program, today's program. There are certain expectations, there are certain outcomes we expect out of the program. First one is, we want all of you to gain comprehensive knowledge of the Six Sigma methodology through a practical, result-oriented approach. And number two, we want all of you to be familiar with the Six Sigma tools and techniques. You should be able to use those tools and techniques, particularly when you are doing projects, particularly when you are doing real-time projects. When you are doing a project, you are actually solving your client's problem, isn't it? When you are doing a project, you will be taking important decisions. So whether it is problem-solving activity or a decision-making activity, we want you to use the right tools and in a right manner. And those are called the Six Sigma tools and techniques. So I'll familiarize all of you with some important problem-solving and decision-making tools. All of you to gain enough knowledge. We expect all of you to gain enough knowledge to attempt and pass the requirements for certified Lean Six Sigma Yellow Belt certification exam, right? And ultimately, when you actually become an yellow belt, we expect all of you to work as very good project assistants. We expect all of you to work as very good project assistants. That means you will be able to assist the Six Sigma green belts in the industry as project interns, as project assistants. And later on, you can also become a project leader. In my opinion, all of you should consider becoming a green belt, maybe, in the next year. Today, then right now you are doing your second year of the course. Probably in the third year, when you upgrade yourself to a green belt, you will be able to directly work on project, right? You can contribute better, and even it will become possible for you to lead projects, once you associate with any organization as a full-time employee. In fact, becoming a yellow belt or becoming a green belt is your gateway to your job offer. So with that note in mind, we are proceeding. So as far as this yellow belt certification program is concerned, this will be the kind of certificate you all will be issued. Your photo will come, and then the training details, and then the yellow belt title will be awarded to you. And then, in fact, the certificate comes with the government logo and other things, and your attendance is compulsory. For all the sessions, you have to be present, and then after completion of the training, there will be an assessment for 45 minutes exam, a timed exam. 25 questions will be asked. You must score minimum 50%, and then only the certificate will be issued. And make sure you comply to all the requirements. You must submit the application form, and then you must write this exam, and then you will be eligible for the certification. Right. There are certain expectations. Madam has already told that you can be on video, and then you can be interactive. Please make sure you follow all those things. If you are not following, what will happen? You will feel like disconnected. So technology is to help us, right? Technology is not to separate us. Rather, technology is to connect us. So we need to stay connected throughout the training program. Whether I conduct the training session, my colleague Dr. Ravi Kumar will be conducting the training session. It is very, very important that we stay connected. You should be able to interact with me, and I should be able to interact with you. If that interaction is not going to, then this platform will become like a TV channel. We are not running a TV show. We are running a live training. And also, there are certain expectations from all of you. You should have basic computer literacy, because these tools and techniques, finally, you will be using it, with the help of a laptop or a desktop, right? So though you are attending this session, some of you might be attending the session with a mobile phone, but for practicing purpose, you definitely require a computer. So basic computer literacy is expected to be known to the participants, and then some exposure on how projects will be carried out. If that is there, well and good. Otherwise, no worries. I'll be giving that exposure as part of the program, because this is just an yellow belt level and not the green or black belt. But what is most important is your commitment to listen, and your commitment to learn from me the various Lean Six Sigma concepts, Lean Six Sigma tools, and then you must be seriously interested to produce results out of your project. Nowadays, we see students participating in industrial project without having any commitment to produce results. They just go there for namesake, or for some learning sake they go, but then they fail to produce results. So you should not be one such thing. You should be committed to produce results. For example, if this training program is happening, I must see to that each one of you actually qualify. I must see to that each one of you actually acquire the required level of knowledge. If I am not going to take care of that, then my training is of no use to all of you. Similarly, when you are doing a project, it is very important to make sure you produce some result for the company for whom you are actually doing a project. All of you are okay with it? Can I get a yes here?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Beautiful. So, the first session Right now it is around 10 o'clock, 9:55. Up to 11:30, 1.5 hour, 90 minutes. I'm going to talk to all of you about what is Six Sigma model. And I will start everything from the fundamentals, right? From the basics. The concept of quality. What is the meaning of quality? And how can an organization use the Lean Six Sigma model as an operational excellence model? So what is operational excellence? How Lean Six Sigma helps in achieving the operational excellence. And then I will also expose you to the Ford production system and Toyota production system, and then the latest lean manufacturing concept. And finally, I will also explain the way of problem solving. Nothing but the Six Sigma way of doing an industrial project. So ultimately, this training is to teach you on how to do a project in an industry. This is what is called, the Yellow Belt training program. From the student's perspective, the training program will equip you on the methodology of executing industrial projects. So as a result, when you actually work on certain projects, you exactly know the step-by-step approach behind doing a project, which is very, very essential, in today's world. All right. So let us start with the history. What is the history of Six Sigma? Six Sigma was conceptualized in a company called Motorola. We all know Motorola, the electronic gadget manufacturing company. So long back, somewhere around 1979, they were into manufacturing of pagers. All of us know pagers, right? Some short messages will be delivered to the receiver, and we call it pager. And then later on, the mobiles were introduced. So at that point of time, Motorola was experiencing, a big quality problem. Like there were a lot of complaints. People after purchasing the product, they were returning, and as a result, Motorola was not able to, maintain a good profit. And then, there were a lot of complaints, and as a result, their market share is going down. So seeing the trend of going down, the chief executive at Motorola, that is the CEO, right, is the Bob Galvin. He threw a challenge. To all the executives in the company, and saying that the company must achieve a 10-fold growth, 10 times growth in a span of next 5 years. Do you understand? How are we performing today? Take 5 years time. Within 5 years, our company should have improved at least 10 times with respect to all the business performance metrics, whether it is profit, whether it is revenue, or whether it is market share, or whether it is the number of products and the number of employees. Everything should improve 10 times, and for that the timeline given is 5 years. So this kind of challenge was given, and at the same time, an engineer like all of you, his name, who was working in Motorola, his name was Bill Smith. His name was Bill Smith. Today we call him as, he is known as father of Six Sigma. Today he is known as father of Six Sigma. At that point of time, this engineer Bill Smith, he presented a paper, a research paper, right? And where he established a correlation between the extent of repair a product undergoes during the manufacturing and its field life. You know what is field life? The reliability of the product. If the field life is good, that means the product is more reliable, right? If the field life is not good, that means the product will fail in the hands of the customer. So he found that the product which is undergoing several cycles of repair during manufacturing is found to have a lower field life. So he understood this, and he presented it in a research forum, like how Newton found the force. So that the apple was falling down, and Newton immediately understood that it's a gravitational force. Similarly, Bill Smith understood that when we repair a product too many times before sending it to the market, that product cannot have a good field life. So the reliability of a product will be high if you produce correct, if you produce it right at the first time. This was the finding of Bill Smith, and this, gained the attention of, many industries, particularly, the Bob Galvin. So Bob Galvin believed on the ability of Bill Smith, and the challenge was actually, given to Bill Smith. What is the challenge? To grow the company 10 times in the next 5 years. And then that was also, the responsibility was also equally shared by another person called Michael Harry. Actually, Bill Smith is an engineer like all of you. Smith is a statistician, an engineering brain supported by a statistical brain. This combination worked very well for Motorola, and then that gave birth to an approach called Six Sigma, right? Where Sigma, in the name Six Sigma, 6 is just a number, but Sigma is a statistical measure. Sigma is a statistical measure which all of us have studied in 7th standard. What is Sigma? Standard deviation. When standard deviation of the data collected from the process is very low, the process will be able to produce defect-free items, right? So this logic we will be able to understand as we progress through the course. And Bill Smith and Michael Harry were completely convinced on this logic, and they developed a methodology and they named it as Six Sigma approach, right? So this is how Six Sigma evolved from this company, Motorola, right? 1979, we were saying. What was the problem with Motorola? The quality was stinking, continuously going down. If you allow it further, then what will happen? Then they have to close down the factory. So they don't want to actually, close down. So they wanted to recover from the quality issues. So that is why, the responsibility was given to Bill Smith and Michael Harry. So look at the turnover. They were making about $4,000 million. The manpower is huge, and they were present in more than 30 locations across the world, right? And then their aim was to become world leaders in manufacturing of communication products such as pagers and mobile phones. So this statement is very important. If this kind of strong intentions are not there, organization really cannot, follow the quality principles, and then they cannot adopt methodologies like Six Sigma, because it involves a lot of learning. We call it organizational learning. That means everybody in the organization should know about the fundamental principles behind quality and certain problem-solving methodology. So then what happened? Seeing the success of Motorola. In fact, Motorola adopted Six Sigma, and then they were able to perform well. And slowly, always the success story spreads, isn't it? So the success story of Motorola and the Six Sigma started spreading. And ABB also adopted, the Six Sigma. You know what is ABB? Asia Brown Boveri. That's the name. It's a Swiss multinational corporation, right? And headquartered in, it is in the Switzerland. They were actually into robotics, power, heavy electrical equipment, and automation related areas, right? And the problem with ABB was they realized, the urgent need for major improvement in their, the way they manufacture the product. They understood that their performances were below average. They were good, but it was below average. That means well below the world-class performance. Particularly, the defect levels. You know what is defect level? The product has certain non-conformities. There are certain characteristics, that exist in the product which are not as per the customer requirement. So those are called defects. So those defect levels were 60% higher than the competitors. See, their defects are not 60%, but their defect levels are 60% higher compared to the competitors. See how they are, finding the deficiency within themselves. They compare their level against another, good companies in the same field, and then they realize the improvement opportunity. Similarly, all of you, you can compare your level against the IIT students. If you feel like, your levels are well below the IIT students, then obviously you should also realize the urgent need for improvement. So this thinking made ABB, to adopt Six Sigma. And moreover, the competitors were able to make 10% higher profit than ABB. Sometimes we might think, what is their competitors are earning money and we are earning money separately. Why should I compare my competitor earning with my earning? That is actually important, right? This kind of benchmarkings are actually important. So this thinking is required. And similarly, scenario 3. Now the organization called GE Medical System, General Electric. See, it is Motorola introduced Six Sigma. General Electric modified Six Sigma methodology. When Motorola introduced the Six Sigma methodology had only 4 phases: measure, analyze, improve, and control. This happened in, somewhere around 1987. But General Electric adopted Six Sigma in 1995. That time the CEO was Jack Welch. The team at General Electric, they modified the Six Sigma methodology from 4-phase to 5-phase. They added define in front of MAC. So what happened? The MAC methodology has become DMAC methodology, because defining the problem is much more important than measuring the problem. Of course, measure is also important, because what gets measured only gets improved, isn't it? And then before offering solution to any problem, it is very important to analyze. When we are analyzing, our focus should be on the root cause. We should identify the root cause. We should validate the root cause. Then only we must think about the solution. If you define well, measure well, analyze well, and then offering solution becomes an easier job. Otherwise, offering solution will definitely be a challenging one. So once the solution is offered, we need to see to that we maintain the benefits. And so another phase, control phase, will complete the cycle. So the Six Sigma methodology, 5-phase methodology is define, measure, analyze, improve, and control. When it become 5-phased, when Six Sigma was adopted at General Electric, that happened in the year 1995. Then what is that Motorola introduced? Motorola introduced the Six Sigma. That time it had only 4 phases starting from measure. And now coming back to the GE's real quality problem. The GE was manufacturing some medical scanners. The scanner speed and life were need to be substantially improved to stand in the market competition, because the competitors of GE Medical System were able to manufacture scanners with a speed of just 10 to 30 seconds. They do the MRI scan and other scanning in just 10 seconds to 30 seconds. However, the General Electric scanners were requiring 3 minutes to complete one scanning. So that means their equipments were slower. If the situation remains same, what will happen? Slowly all the customer will move on to the other brands, isn't it? So the GE don't want to give up. So they wanted to improve. What they wanted to improve? They wanted to improve the scanner speed. No, actually they achieved it. And moreover, their another pain was, the life of the product. The life means, the field life, we can say, field life, or otherwise, when you actually manufacture, there are several components assembled together, makes this medical scanner. One important costlier component is, a bulb. A bulb was used actually, that is very important for the scanning process. That bulb, it was costing around $60,000. What is the cost of one bulb? No, so much. This was, failing before shipment. The equipment is not yet shipped. It's, the system is built, the scanner is made, but when you do the final product testing, the bulbs were found to be failing. Every year, around 20 million bulbs were failing even before. sending the shipment. And see here, what will be the amount of cost of poor quality? 60,000 bulbs they have to replace. 20 million bulbs they have to replace. And each of them is costing, several dollars. So there is a lots of cost of poor quality. So these are the reason why these companies adopted Six Sigma. All of you understand why Six Sigma was adopted by all these big brands? I need a response here.
Yes, sir.
Right? Right. Then, actually by adopting, what all these companies got? At Motorola made a saving of $2.2 billion every year from manufacturing projects. They floated projects in manufacturing activities. And what was the result? $2.2 billion annually. And $1 billion in non-manufacturing. You know what is non-manufacturing? The accounting, delivery, packaging, billing, all these things, the supply chain, right? So from the customer order till manufacturing of the product, that is called the value chain. Once the product is manufactured, we send it to the customer. That is called supply chain. They floated Six Sigma projects in value chain also, as well as supply chain also. In manufacturing activities also, as well as in non-manufacturing activities also. That simply means Six Sigma can be implemented across all industries, across all departments. What is required is your thorough understanding on what is exactly Six Sigma and what is that methodology, the principles behind, and the purpose of the tools and techniques. If this knowledge is imparted, then definitely this can be implemented in any industry, right? And then ABB, the benefits realized by ABB were 68% reduction in defect levels, 30% reduction in the production cost, $898 million savings annually. Now, General Electric, actually, implementing Six Sigma is not that easier. First of all, you have to train all your employees. Like all of you are now, undergoing Yellow Belt training program. Do you think this is enough to roll projects? Now, all of you are project assistants. What is required? Real project team members are required. Then they have to be green belts. We also require project leaders. They are called, green belts again. And then for complex projects, we want black belts to lead the project. And then the black belt, the green belt, yellow belt, all of them have to be mentored. For that, we need master black belts. And of course, all of them have to be guided effectively by the top management. So we need to convert the top management into champions and sponsors. All these things have to be done. For that, there will be a cost associated. General Electric spent about $500 million and they got back $2 billion in 1 year and $12 billion in 5 years. These are not small money even today, isn't it? All these things happened in 1980s and 90s. But even today, these numbers are really very high. So what is Lean Six Sigma? Lean Six Sigma is an operational excellence model. You know what is operational excellence model? Performing better than anyone else in the market. Your intentions are to perform better than anyone else in the market. In your class, there are 100 students studying the course and you want to stand number one. Then your thinking is operational excellence. There are 100 competitors producing similar product in the same market segment. But you really wanted to be number one in terms of all aspects, quality, productivity, cost. That means you are wanting to create a win-win situation to all the stakeholders. Then the thinking is called operational excellence model. So the Lean Six Sigma can be used to achieve operational excellence. So that's why I've written like this. Lean Six Sigma is an operational excellence model. It is an aggressive campaign to boost profitability, increase market share, and improve customer satisfaction. To do all these things, you must use quality as the strategic business focus. To achieve market share, to boost the profitability, right? To satisfy your customer, what is the weapon you are using? What is the strategy you are using? Quality is the strategy. What is quality? Doing right at the first time. So ultimately, if you understand this, your organization can benefit in this manner. The customer satisfaction will be higher. The cost reductions will happen. Your manufacturing cost will become very low. As a result, your profits will go high. At the same time, this thinking will help you to comply to all legal and environmental requirements. Whatever the government policies, guidelines, you will be able to comply. At the same time, you will have your profit maximized. This is true with any kind of industries. All of you are with me so far? All of you are able to understand whatever I'm talking?
Yes, sir.
Yes, sir.
I want to know whether all the students, all of you are comfortable with me. Just type in the chat box.
Yes, sir.
Able to follow me? Please type follow in the chat box. Please type follow in the chat box. There is no point, in the end saying that, sir, it was not understood. No, you have been talking about industry. We are students. You should not tell like that, right? You should be able to follow everything we are going to, speak to you. Oh, fantastic. It seems all of you are very attentive, right? And that's why all of you are able to type immediately. Thank you so much. So we move on. Now, this is very, very important slide. So what is Lean Six Sigma or Six Sigma? Six Sigma is a management philosophy. Six Sigma is a management philosophy. Philosophy means belief. Right? What is that we strongly believe? Six Sigma is a management philosophy to meet business objectives by reducing variation. You know what is the philosophy? If you reduce variation, you can meet all your business objectives. You know what is variation? Consistent. Whatever I speak today, the same thing I'll speak tomorrow also. I'll never change my thinking. Then what will happen? You will actually achieve out of your thinking. Whatever you are thinking, that will start happening. Same way, when you manufacture a product, always there will be variations. There will be variations. I'm introducing a statistical term now to all of you. What do I introduce? Variation. What is variation? When I produce 1,000 products, do you think all 1,000 products will be exactly same? Very difficult, isn't it? Though you use high precision equipment, highly skilled manpower, modern technology, then also every single product will be distinctly different from the previous product. Am I correct? This is called variation. When you produce 1,000 products, all 1,000 products will be distinctly different. This will always happen in any industry, any business, with any product or any service, or you can also connect this variation to product characteristics. It can be length, it can be width, it can be diameter, it can be surface finish, it can be the strength of the material, whatever and whatnot. Anything that is measurable will have variation. So if the variation gradually increases, one day what will happen? The customer will definitely get disappointed because the variation is too much. As long as the variations are low, customer can't see it, isn't it? For example, the customer requirement is 100 mm. Your products will have dimension of 100.01, 100.02, 99.995. There is a variation, but how much is the variation? Very small. So customer will happily buy your product. Why? The variations are very low. Suppose if the variation increases, let's say 100 becomes 107, 100 becomes 92. Do you think that still the customer will buy your product? He can't buy. Why? The variations have increased. As the variation increases, the product characteristics will start deviating from the required value. That is why, in Six Sigma philosophy, we say variation will cause defects. If you allow the variations to increase, it simply means you are allowing the defects to increase. How many of you understand my statement? If you allow the variations to increase, it simply means you are allowing the defects to increase, right? How many of you understand? Please respond or type in the chat box. All of you understand? You can type yes again. All of you are able to understand this statement? Very, very important. Very good. Gokul Krishna, Shakeen. Very good, very good. All of you are fantastic. Please, if you are not able to understand any of the statement which I am explaining, please ask me questions, right? You don't have to tolerate the confusions. Rather, you can get it clarified then and there. So, Six Sigma is a disciplined data-driven methodology for decision making and process improvement. If you want to improve business performance, you need to decrease the variation and defects. See here, this curve, this is a bell-shaped curve. We call it normal distribution curve. All of you could have studied in the schooling, right? Only based on the normal distribution curve, we the concept of probability lies. So this is a business process, a bell shape. This is another business process. This is also a bell-shaped curve. This bell-shaped curve is very wider, whereas this bell-shaped curve is narrower. The narrower means the variation is less. Wider means variation is high. What is required for us? We need high variation or low variation? We just now understood that variation causes defects. So we need low variation. See here, for the same requirement, customer will always have certain specification. Customer will always have certain specification. Let's say you want a steel rod. The steel rod, the diameter of the steel rod should be 100 mm. What is the diameter of the steel rod required? 100 mm. And you are also giving a tolerance, 100 mm plus or minus 0.5. Your tolerance is very high, but anyway, you are okay with it. So now you are telling the manufacturer that your requirement is 100 mm diameter and plus or minus 0.5 is tolerable. So how much variation is tolerable? Plus 0.5 on the right side, minus 0.5 on the left side. So the target value plus tolerance is called upper specification limit. All of you are able to see USL? Now this target is how much? 100. How much is the tolerance you have given? 0.5. So this point will be 100.5. Similarly, this point will be 90.5, 99.5. How do I get 100 minus 0.5? 99.5. Look here, since your curve is wider, a portion of the curve is going beyond 100.5. If you produce products beyond 100.5, do you think the customer will buy? Yes or no? The answer will be no. Similarly, the curve is going beyond this lower specification limit also. You know what is lower specification limit? 99.5. Since your process is producing units beyond the specification limit, all those units will get rejected. There will be lot of rejection. Why lot of rejection takes place? Because the process is wider. Because the variation is higher. If the variation is higher, that means standard deviation is higher. What is standard deviation? Sigma. Sigma is higher. As a sigma higher means variation is higher because standard deviation is a measure of the variation. When variation is too high, your process will produce lot of rejection. Coming on to the other side, the variations are low. When I mark the rejection, when I mark the specification limits, you see almost every part of the curve is inside the specification. That means all the products will now be accepted by the customer. If you expect your customer to accept all your product, make sure your process is narrower. How can you make sure? How do you know your process is narrower? Collect data from the process, calculate standard deviation. If the standard deviation is small, your process is narrower. If the standard deviation is high, your process is wider. So a narrower process is considered to have a higher capability than a wider process. If the capability is higher, we call it higher sigma level. Higher sigma level. You should not be confused between sigma and sigma level. Sigma is variation. Sigma level is your capability. When you reduce the sigma, your capability increases. That is why, 6 sigma is written here. On the other side, your capability is low. Only 2 sigma is written here. All right. So that means our intention is to produce products first time, right, always. That means there won't be any wastages, there won't be any rework, and your manufacturing cost will be low. And moreover, since you know about how your process is distributed, your process predictability will be very high. Your process predictability will be very high. Predictability means how it is going to perform, maybe after some period of time. That can be predicted now itself, because knowing the shape of the distribution, we can do the prediction. Your process results will be consistently better, right? And as a result, your customers will be happier. How many of you understand this particular slide? I want to know. If there are questions, I would like to take the questions. But if all of you have understood the question, understood the content of the slide, please type it in the chat box, understood. Or you can shortly type US. How many of you understood? If there are any questions, I would like to clarify. Please feel free to ask your questions. Questions can be silly, questions can be challenging. I am capable of answering both. You can ask me the silly question also. If somebody asks me, sir, what is standard deviation? I am ready to explain. But there has to be questions. So no questions at this stage. All of you are fully comfortable with me? Should I proceed then? Yes, thank you so much. I'll proceed. So what is Six Sigma? Six Sigma is essentially or basically a metric. Six Sigma is a metric. Six Sigma means a measure of your capability. If the measure of your capability is very high, for example, what do you think about my capability to help all of you understand Six Sigma? My capability, if you think it is high, that means all of you can learn from me. Similarly, if your process capability is high, all the products will be accepted by the customer. So Six Sigma is a measure of a capability. You can call it, you can consider it as a metric. Bill Smith and Michael Harry, they estimated that if the process capability is at Six Sigma level, the defects will be reduced to or restricted to 3.4 DPMO for sure. If your process capability is Six Sigma, the defects will definitely be limited to 3.4 defects per million opportunities. That simply means when you produce 1 million product, how many defects will be there? 3.4 defects. To be very precise, when there are 1 million opportunities for a defect to happen, only 3.4 defects will actually happen. You have made your process that much capable. That capability is called Six Sigma capability. Six Sigma is a methodology. Just before we spoke, define, measure, analyze, improve, control. People are guided, step by step. When you do a project, when you are doing when you are solving a customer's problem, or when you are solving a business problem, or when you are trying to reduce the cost of poor quality, you follow a specific project execution methodology. This is what I strongly recommend to all the students. When you are also doing a project, particularly industrial project, please use the same sequence. Define, measure, analyze, improve, control. Your approach will be definitely appreciated by anybody. That means you will gain some recognition in the industry just because you are following a structured approach. So Six Sigma is a methodology. The methodologies always guide us in the correct direction. Six Sigma is a way of management. Company believing in Six Sigma, they first train all the employees. At least those who participate in improvement project, they will be trained to become yellow belt, green belt, and if the project is complex, then some people will be trained to become black belt, and then things like that. So Six Sigma is a way of management. Please note, Six Sigma is a philosophy. Wherever there is a variation, there will be defects. Isn't it? So as the variation increases, defects will increase. So this thinking, is more, all of them are applicable in all industry. You can call it as philosophy also. Six Sigma expects you to be customer focused. Six Sigma expects you to be process centric. Six Sigma expects consistency. Six Sigma expects predictability. All of them are required in all the industry. Six Sigma tries to maximize profit. Tell me a company which doesn't like, profit maximization. So that means, Six Sigma is a philosophy. That is why it is very popular across all industries. See here, metric 3.4 DPMO is the kind of performance you will achieve. Methodology. Fundamentally, there are two methodologies. One is DMAT, another one is DMAT-V. If you are having a product and if there are failures, if there are problems with respect to the product, use DMAT methodology. If there is no product exists, you want to develop a new product, use DMAT-V methodology. Right? So DMAT is for existing product and process. DMAT-V is for new product and new process. And yellow belt, green belt, black belt, master black belt, champion, sponsor, you can effectively manage your team. Right? At least the project execution team can be managed for each and every belt level. There are roles and responsibility assigned. What are the tools and techniques they should know? These are called the body of knowledge, right? So those were actually developed by Michael Harry. You know Michael Harry, the statistician, right? After Bill Smith, Michael Harry popularized the Six Sigma. And then Motorola created their own university, Motorola University. Imagine, an university was created to equip people, on the Six Sigma methodology. The only course the university run is yellow belt, green belt, black belt, master black belt. They want the university, runs courses only, exclusively to train their own employees. Then it's applied across all philosophy. As a result, you get profit growth. As a result, your profit will get maximized. And the maximized profit is sustainable. That means, the profit is always, evergreen profit. It never, goes down. There will be only, upward growth, no downward growth. The profit will become predictable. You can predict what is going to happen next year. And you will also achieve desirable. For example, my profit is 100 crores. I want to achieve 500 crore. That means my desire is to make a profit. Do you think you can jump from 100 to 500? Yes, it is possible. Six Sigma can even help you achieve breakthrough results. All of you are okay with this slide? Shall we move on?
Yes, sir.
Yes, sir.
Very good. So that is why I strongly
Yes, sir.
want all of you to master Six Sigma methodology, because all of you have to settle in a very good job. All of you have to grow in your career very fast, and even before age of 30 or 35, you should occupy very big leadership roles in an organization. For that, your investment on this course, be it money, be it time, be it the effort, it is definitely worth it. Right? Trust me, this effort will definitely guide you and make you succeed in the shortest possible time. All that required is, a strong belief on this methodology. See, imagine how many companies I have shown. There are many other companies, succeeded, which I have not listed here. So definitely it will work for you also. So master your skill, understanding on Lean Six Sigma methodology, the tools and techniques. So when you want to do an industrial project, the first thing you need to do is you must define the project. Defining the project is nothing but understanding the problem. A well-defined problem is half done, isn't it? When can you say a problem is defined? You can say the problem is defined if you make the problem measurable. If you make a problem measurable, it simply means you have defined it. If you can't even measure a problem, it simply means you have not understood the problem. So making the problem measurable is called define. That means a pain metric should be identified. What should be identified? A pain metric should be identified. For example, all of you are students. You are studying, a mechanical engineering course or robotics course, automation course, automobile course. Let us say, there is a pain. Pain in the sense students are not able to pass. Students are not able to pass. They put a lot of effort, but then they are clear a course. Now, what is the pain? How do you measure the pain? The class average mark. What do I say? Class average mark. You know what is class average? The mark scored by individual student is added up, and then I divide by the number of students. The resulting number is called class average. Class average. If the class average is above 80 marks, what does it mean? All the students are able to clear the exam, isn't it? So always you should identify a pain metric, which is nothing but a number. We call it Y variable. We call it Y variable. That number should help anyone to correctly understand the problem. That is called define. And then once you understand that, you can proceed to the next stage. What is next stage? Measure. You know what is measure? You actually measure the pain metric. Now that I understand, in a particular department, particular year, particular course, the students, passing rate is very low. Why the passing rate is very low? Students are scoring low mark. So what is the mark? Instead of looking at 1 or 2 students, I will look at the average mark. Now I will actually collect data. When I collect data, I should collect the data correctly. Isn't it? Most of the time, when people collect data, they collect with some errors. Why the error happens? The measuring equipments or the gauges they use may not be appropriate, or they may not know how to use the gauge, or they were not taught how to collect the data, or the data collection technique, we call it the sampling technique, that is wrong. So there are several ways by which your readings can go wrong. Through the readings only we see the problem. If the readings goes wrong, then problem understanding goes wrong. By wrongly understanding a problem, can you solve it correctly? It's impossible, isn't it? No, problem solving or doing a project is something similar to driving a car in a highway. When you want to drive a car in a highway, it is very important you get a clear vision of the road. You should be able to see the road and then drive the car so that you can reach the destination on time. If you have a problem in seeing the road, tell me honestly, will you be able to drive the car? Definitely no, difficult. If you still proceed, what will happen? You will meet with accident. Same way, when you are doing a project, particularly a problem-solving project in an industry, your data should be clean and your data should be credible. Only when the data is credible. Credible means no error. The permissible amount of measurement error is 10%. The permissible amount of measurement error is only 10%. So you need to check whether your data is clean and credible. That means the goal now is measure without errors. How many of you understand? When you collect the data, when you execute the measure phase, you must measure without error. And now you understood the baseline. Now you move on to the analyze phase. Now, what should be your goal? Your goal should be to identify and validate the root cause. Because always, there will be several causes. Some of them may be critical, some of them may be not critical. For example, as far as the effectiveness of the training program, how do I speak? How do I speak? No, anybody can explain the concept. But how do I explain? Is that my explanation understandable by the current participant? That is very critical. But the color of the shirt I am wearing today, do you think that is a factor? Suppose if I wear a black color shirt here, it might, people may not like black color. But do you think that factor is a critical factor? No. So some of the factors might be critical and some of the factors might not be critical. For example, the trainer can be male or trainer can be a female trainer also. Do you think the gender of the trainer is critical for the learning? No. But definitely how the trainer is presenting the concepts to the beginners like all of you, that is very critical. So those critical factors are considered the root cause. You should be able to identify and validate critical factor. Work on the critical factor. Don't waste your energy. Don't waste your resources on the non-critical factors. Now you will come to know about the real root cause of the problem. Is that clear? The purpose of analysis is identification and validation. Validation is proving. Validation is proving. If you identify a criminal, it is important to prove the crime also. Then only the judgment will be released. Then only the criminal will be punished. Same way, if you say the factor is critical, you must prove the criticality. That is called validation. Having defined the problem, having measured the problem, having analyzed the problem, you know the root cause now. If you know the root cause, tell me, will you now be able to offer a solution? Definitely yes. Because I know the problem, I measured the problem myself. Now I know the root cause also. If the root cause is known, I will fix it. Fixing the root cause is nothing but improve. So statistically we call it treatment. Statistically we call it treatment. Like how a doctor gives treatment to the patient. You are also now giving treatment. Statistically it is called a treatment. Nothing but optimizing the critical factor. Nothing but optimizing the critical factor is what is called improve. Now the problem is solved. Now the medical doctor has helped the patient to recover from the disease. Now the doctor will give lot of useful information. Useful information like how to eat, how to sleep, and what kind of tablets to be taken on a daily basis for next 1 month, and what kind of food he must eat. That means the doctor is giving some disciplinary practices which they have to follow on a day-to-day basis so that the gained health can be sustained for a longer period. Same way, when you solve a problem in a company, when you solve a quality problem in a company, can you give some daily routine habits? Can you give some tips, the daily routine habits, what the operators are expected to do on a daily basis whenever they run the machine, whenever they run the process, what are they supposed to take care? You have to pass on the knowledge you have gained. What knowledge you gained? You gained knowledge about the root cause. Can you advise them to keep an eye on the root cause and control the root cause continuously? As long as you control the root cause, your problem will be under control. This is called control phase. This is called control plan. Right? When you actually buy any equipment, the equipment comes with a manual. The manual will have troubleshooting. If this problem happens, you adjust this. If this problem happens, you adjust this. Same way, can you give some troubleshooting ideas? Can you provide them some daily disciplinary guidelines, daily routine, how to maintain the machine, how to set the machine, everything, procedures are created. That is called control plan. How many of you understand the power of DMAC methodology now? All the 5 phases are important. Do you think some of the phases can be removed? when you are actually doing a project, or all phases are required? Come on, guys. Give me an input. What do you think? Is that all 5 stages are required? Define, measure, analyze, improve, and control. Come on, some response. You can type in the chat box or you can speak out. Is that all 5 phases are required? Type yes or no. Come on, be a little faster.
Sir.
Very good, very good. So that means when you do a project in an industry, make sure you follow all the 5 phases. Make sure you carry out all the activities in each and every phase. Then only your project can be successful. Otherwise, it will be a mere waste of time. Now, moving on. In this training program, we are going to train all of you. We are going to train each one of you in every phase. And we have carefully divided the phase into 3 simple steps. 5 phases, 3 steps each. That means the whole training program is learning 15 simple steps. How many steps? 15 simple steps by which you will systematically reduce defects from any business process. You can reduce defects, then it is Six Sigma project. You can reduce defects as well as waste, then it is Lean Six Sigma project. Right? You can also reduce the risk associated, isn't it? So all are possible. Defects, risk, and waste. You can eliminate all the 3 or reduce all the 3. That is called a Lean Six Sigma project. All your projects can be executed as a Lean Six Sigma project to gain a lot of respect and recognition from the industry for whom you are actually doing the project. So 3 steps in the define phase written here, 3 steps in the measure phase written here, and 3 steps in the analyze phase written here, 3 steps in the improve phase written here, and finally final 3 steps in the control phase. See here, after completion of the final step, you hand over the process and the project back to the process owner, and then you celebrate the success and come out. If you do projects like this, definitely the industry would like to retain you. The industry can definitely compensate you for your efforts. Even during the project period, you can be paid for it because your approach is structured, systematic, and it is result oriented. And not anybody X and Y can work in this manner. Only certified Six Sigma experts can do. That is why, though all of you are students, we are bringing this very good program to your platform. Otherwise, what will happen after 5 years, after struggling for a good job, you might realize and come back and learn this. But you all must be thankful to your institution, thankful to the professors who arranged the program, because they are providing you a good content the very right time. You are in the 2nd year. This is the time you must study yellow belt. You are in the 3rd year. That's the time you must study your green belt. Then final year, that's the time you should actually do your project. Prepared well in advance. We all must be ready for the battle well in advance. You can't manage the battle and then manage your preparation parallelly. It is impossible. Battle begins, can begin anytime. So we have to be ready well before that. We need to be proactive. So belt levels. So these belt levels are very important. So the fundamental level, informal qualification is white belt. So for example, all of you have listened to me for about last 1 hour. I am sure all of you are now convinced that Lean Six Sigma is definitely required for you. Right? If the leaders in the organization believe that Lean Six Sigma is important for their profit, important for their quality improvement, profit growth, and cost reduction, then those leaders in the organizations are now considered as white belt. Not necessarily leaders, everyone in the organization should at least be a white belt. Otherwise, they may not respect these approaches. Without gaining the respect and without gaining the buy-in of the people, implementation cannot be successful. So it is very important you convert everybody into white belt before implementing Six Sigma or Lean. But that is not sufficient, isn't it? That just white belt level is not sufficient to participate in a project. So the immediate next level, that is what all of you are undergoing, that is called yellow belt. As I already mentioned, it is something equivalent to a nurse. Nurse can ably assist the doctors. Similarly, as an yellow belt, you can assist the green belts in the project. Who are green belts? The project team members, the project leaders, quality improvement project leaders. But if you really wanted to grow further, grow fast, you can become a green belt. As a green belt, you are now an effective team member. You are now able to lead green belt projects, simple and moderate projects, right? Of course, there are higher levels. This always you can learn at a later stage. After becoming green belt, I don't recommend this at this point of time. You become a green belt, do at least one project, then come for the black belt. Now a black belt will handle complex project. And who will produce black belt? Who will produce green belt for the company? Who will mentor them? Who will guide them? That's the master black belt, right? And then all of them should be supported by the top management. So they are called project champion and project sponsors. Hope it so far is clear to all of you. Now I have few questions. I want the students here to answer my question, right? Either you can unmute and answer, or you can type your answer in the chat box. Come on, guys. The question is, who is known as father of Six Sigma? Who is going to answer this question?
Bill Smith.
Bill Smith.
Very good. Beautiful. Beautiful. Very good. Bill Smith. Then tell me, who is Bob Galvin? Who is Bob Galvin?
Chief Executive, sir.
Chief Executive. Very good. Kumar Yuvraj. He is the CEO at that point of time. Then who is Michael Harry? Michael Harry is an engineer or statistician?
Engineers.
No, Bill Smith is the engineer. Michael Harry is the statistician.
Statistician.
Both of them, they developed the Six Sigma methodology. Who is this Jack Welch? The CEO of General Electric. It is General Electric which converted the 4-phase methodology into 5-phase methodology. Six Sigma methodology has so many phases. How many phases it has got? Come on, you need options. How many phases Six Sigma methodology has?
5.
Very
5, sir. 5.
How many steps? How many steps?
15.
How many steps? 3 in each phase. So totally how many steps?
15, sir. 15, sir.
15 steps, 5 phases.
15 steps, sir.
What are the phases? What is first phase? What is the first phase? Define. What is the next phase? Why answers are
Measure.
coming?
Measure.
Measure. What is the third phase?
Analysis.
Fourth
Analysis.
phase.
Improve.
Fifth phase.
Control.
Beautiful, right? All of you are now listening very carefully. And now one more question. A white belt is one who respects Six Sigma, who understands the importance of having a systems approach, process-centric approach towards quality. Is this statement true or false? Come on. There are only two options, true or false. Come on.
False, sir.
Sorry, I'm not able to hear you. True or false? Or you can type it in the chat box. True or false? True means T, false means F. Type in the chat box. Saravanan says false, but all others says true. That means Saravanan has to change. A white belt,
True, sir.
if you strongly believe that what you are learning now is going to be helpful in your career, then you are a white belt. You have joined the program. That means, you are able to understand that, this is going to be helpful. So you are a white belt. True. And yellow belt can lead Six Sigma project. Is this true or false? Come on, participate, speak faster.
False.
Yes, very good. It is false.
False, sir.
A green belt can lead Six Sigma project. Is this true?
True, sir.
True, sir. True.
Oh, very good, very good. Fantastic. Yes. Now I want to take on another stage. See, companies practicing Lean Six Sigma, they actually do 4 types of project. How many types of project? 4 types.
4 types.
And the 4 is divided into 2 categories. One category has 3 different items. See here, 3. And another category, only 1 item. That means, broadly, there are 2 categories. One category involves additional lot of investment. One category involves lot of investment. Other category without investment. Tell me which one the organization will like most. They want to do project with investment or without investment? Without investment. And without investment, there are 3 types of project available. With additional investment, certain projects are available, right? We'll see. See the first case. A company want to produce more product, but they want to utilize only very less resource. You understand? More output. The output, they want more. They want more output. At the same time, input is less. See, all of you know process. Process means I give input and then the process will produce output. Certain project will aim for increasing the output. See here, this one. Increasing the output by reducing the defect. When I reduce the defect, my output will increase. That project is called Six Sigma. That project is called Six Sigma project. That will follow a methodology, DMAC. Another project is there. I don't want to increase the output, but I want to decrease the input. When I decrease the input, what will happen? My manufacturing cost will go down. Am I correct or not?
Yes, sir.
When I increase the output, then my profit will increase. But when I decrease the input, my manufacturing cost will go down. Such projects are called lean projects. Such projects are called lean projects, and this will also follow DMAC methodology. So reducing the input is called reducing opportunity for defect. That is otherwise called waste elimination. There are certain projects where they will try to reduce the input also, they will try to increase the output also. Such projects are called Lean Six Sigma project. All of you now understand what is Six Sigma project? Increasing the output. What is Lean project? Decreasing the input. Then what is Lean Six Sigma project? Decreasing input, at the same time increasing output. All of them will follow the methodology called DMAC. All of you are clear with this?
Yes, sir.
Very good. On the other hand, I will make some additional investment. See, for these 3 projects, we are not making any additional investment. We are only changing process. We are training people, and then we are maximizing our results. Whereas on the other side, suppose a company is let us say a car manufacturer. A car manufacturer, they currently have 2 types of car, a 4-seater and a 7-seater. Now, next year onwards, the company would like to introduce a 3rd variant. So far, how many variants available? Only 2 variants. But next year onwards, they want to introduce 3 variants. Now, this is called new product development. Am I correct? This is called new product development. New product development requires investment. New product developments are always, happens consumes a longer period. In some companies, what will happen? Every shift, their production capacity is, 5,000 units. Every shift, what is the production capacity? 5,000 units. From next quarter onwards, the company want to double the capacity. Rather, they will increase the machine, or they will hire more people, or they automate certain process. But now what is their goal? They increase the capacity. That means capacity expansion. Capacity expansion, new product development. These are called DFSS project. What is it called? DFSS. You know what is DFSS? Design for Six Sigma. And one of the methodology for DFSS is DMAT-V. Clear to all of you? There are broadly 4 types of project. What are the projects? Six Sigma project, Lean project, Lean Six Sigma project. On the other hand, DFSS project. All of you understand all the 4 types?
Yes, sir.
Very good. And my suggestion to all of you, when you are doing a project in 3rd year or final year, you must necessarily pick up from the left side. Don't get into the right side. You know why? Investment is required. Another thing, the duration will be several years sometimes. But what will be the duration of your project? 2 months or 3 months. When the duration is less, please take up a lean project. When you have considerable duration, then you take up Six Sigma project or Lean Six Sigma project. Is that guidelines clear? Yes. So Lean Six Sigma is a systematic approach to attain best-in-class performance in productivity, quality, and delivery of products or services with lower operational risk, lower manufacturing cost, and increased revenue and profit. So as a company, you can decide to believe Lean Six Sigma, or you can decide to continue the traditional model. You know what is traditional model? In traditional model, profit is considered to be a function of the price of the product and the cost of the product. Profit is considered to be a function of the price and cost. The difference between the two will be the profit, isn't it? Price is 100 rupees, cost is 80 rupees. What is the profit the company is getting? 20 rupees, right? In traditional model or classical business model, they believe that for better quality, we require modern technology, or for better quality, we modern technology, modern machinery, highly skilled resources. That means they strongly believe that cost and time are directly proportional to quality. That means when I want to increase the quality, what will happen to the cost? Cost will increase. When I want more quality, then manufacturing time will be more. These are the belief in traditional model. But coming on to the other side, Lean Six Sigma model. Here, what is the equation? Profit is a function of defect reduction. How many of you understand the difference? Profit is not only a function of price, not only a function of cost, it is mainly a function of defect reduction. Am I correct? When I reduce the defect, my profit will be more. And better quality means less defects and rework, less buffer, and low cycle time. Defect, all of you know. Rework also, all of you know. Buffer means stock. If you keep more stock, then your money will be blocked. When your money is blocked, you have to pay interest for it. As a result, your profit will go down. So better don't keep more stock, whether it is raw material or finished product or work in progress. Then what should you keep? You should keep only what is required. So you should know the required quantity, the economic required quantity, and then cycle time, the time you require to complete a process, that should be low. So here the belief is cost and time are inversely proportional to quality. That means when you have highest level of quality in everything, you can produce the product at a very competitive price. If you have quality in what you are doing, you can produce the product faster. So quality and time are inversely proportional. That means when quality is high, what will be the cost? Cost will be low. What will be the manufacturing time? That will be low. How many of you are able to digest my statement? Hope all of you are able to understand. And now moving on. So now we have talked so much about quality so far. Now I would like to ask a question to all of you. Now there are 4 different cars I am showing in the screen. You can choose which car is a quality car according to your understanding so far. Please type in the chat box. Which car is a car?
White car. White car, sir.
Okay, you type, okay.
BMW is that one? Sir?
BMW. Very good. So I got 3 people answering, all of them said, BMW. And maybe somebody could have typed in the chat. Many people have typed in the chat box also. All of them have typed, BMW. Now let me ask another question. Which car is a luxurious car?
BMW, sir.
BMW, sir. BMW, sir.
I
BMW,
asked
sir.
2 different questions. For both questions, you are saying that the answer is BMW. That means we lag in terms of differentiating the terminology between quality and luxury. Luxury is different, quality is different. Am I correct?
Yes, sir.
So luxury, luxury, is related to my lifestyle. Luxury is not related to my, luxury is related to my lifestyle. But quality is related to my requirement. Do you understand the difference? Luxury is related to my lifestyle. But quality is related to my requirement. Now let me ask the question slightly different manner. Suppose imagine you don't have any limitation on money. You don't have any limitation on money. Tomorrow you would like to buy a car. Will you buy a car? First time you are buying a car. Will you buy the car for lifestyle, or will you luxurious lifestyle, or will you buy a car for your family requirement? What will be your option?
Family requirement.
Very good. My family requirement is very important. So if you buy a product according to the requirement, then the product is considered to have quality. At the same time, quality should be looked at from the customer's perspective. Certain segment of people may like Renault Kwid. Certain segment of people may like Maruti, Desire. Certain segment of people might like i20, but definitely certain segment of people might like BMW. Each segment will have certain requirement, isn't it? Each segment will have certain requirement. For example, Renault Kwid. The expectation is, the mileage should be minimum 15 to 18 kilometers. But BMW, is that the requirement is mainly mileage?
No.
Different, isn't it? So, the requirement and its priority. The requirement and the priority will change from customer segment to customer segment. So, fundamentally, what you need to understand is quality is a result of, meeting customer requirement. As long as the requirements are met, then you can understand the product has got quality in it. In my opinion, all the 4 cars I'm showing have quality. That is why they are selling in the market. Am I correct?
Yes, sir.
That is why they are selling in the market, right? So quality is meeting customer requirement. For example, do all of you realize quality in our training program?
Yes, sir.
You're all students. Six Sigma is meant for higher level professionals. Many people think that Six Sigma is should be taught only to high level professionals, not to anybody who desire. But now all of you are able to comfortably learn. That means the training has got the quality. Always what you deliver when it meets your customer's requirement, that is considered to possess quality in it. So simply stated, quality comes from meeting customer expectation. It happens because of 4 activities. First activity, understanding the requirement. Second activity, you must design products and services. The design feature should satisfy the requirement. Now, the design should come to a reality. So you require process. It could be manufacturing process. It could be it could be assembly process. It could be packaging process. It could be billing process. Ultimately, it is process. Developing processes that are capable of producing the goods and services as per design, as per customer requirement. Now you developed the process. Now you want to go for a mass manufacturing, or you want to produce more. That means the developed process should continue to operate with the same level of capability. So you need people to manage and control the process. They are called employees. They are called managers. They are called engineers. So please understand, all of you, your primary job is this thing. What is that? Managing and controlling processes. All of you now understand what will be your role and responsibility when you join a company. Your role is manage and control process. Please tell me, a company will do the first activity only for one time. Only while developing a product, this first activity is required. Then they design the product. How many times the company will design a product? This is also only on smaller number of times. Most of the time, our product once. If required, there will be some redesign. And then they will develop process. First 3 are one-time activity. The last one is daily activity. How many of you understand my explanation? The first 3 are one-time activity. The last one is daily activity. Now tell me, where the job opportunity will be more? The job opportunities will be more in the first 3 lines or in the last lines?
Last line, sir.
Last line.
Beautiful. That means if you really wanted to grab a lot of job opportunities that today exist, you all should know how to manage and how to control a process. Nothing but process improvement. This is what Six Sigma exactly is doing. How to manage and control the process. I need to manage a process. I need to control a process so that the capability of the process consistently, is high. Very good. And now process improvement is your job. All of you have understood. Process improvement is your project. Process means a set of activity. All of you have studied. Process means a set of activity. There will be input, there will be output. The input is converted into output. If the output produced satisfies the customer, the process is considered to be effective. For example, the last 1.5 hours I have been speaking. The output is, the content I have delivered. Is that all the content I have so far delivered? All of you are able to understand? Yes?
Yes, sir.
Yes, sir.
That means the training.
Yes, sir.
That means the training is effective. Suppose if I talk whatever I know and you people are not able to make out anything, the training is ineffective. If I produce a product and if the product characteristics meets your requirement, then the product is effective. If the product characteristics doesn't meet your requirement, then the product is ineffective. The ineffectiveness in the product is termed as defect. How many of you understand what is a defect? The feature of a product customer do not like. Then what is that called? Defect. For example, if I have a spelling mistake here in the title of the slide, when I have a spelling mistake, what is that called? It's a defect. Any non-conformance that is present in the product is called a defect. Technically, any ineffectiveness is considered a defect. All of you understand what is a defect?
Yes, sir.
Now
Yes, sir.
moving on, efficiency. What is efficiency? How much resource you are consuming? In order to be effective, how much resource you are consuming? In order to be effective, if you consume more resources, that means you are inefficient. If you consume less resource, but you are able to be effective, that means product is defect free. Product is defect free, but the resource consumption is very less. Resource means time, resource means material, resource means effort. Everything is resource, isn't it? You consume resource that is just required, not even 1% extra. What is just required? You only consume that amount of resource to reach the desired level of effectiveness. That is called efficiency. If you are consuming more resource, that is called inefficiency. The inefficiency is termed as waste. The inefficiency is termed as waste. We need effectiveness, we need efficiency. So we must remove defects, we must remove waste. Reducing defects is Six Sigma approach. Reducing waste is lean approach. If both are important to you, if you want to reduce both, your approach is called Lean Six Sigma. Because in any organization, effectiveness cannot be compromised. At the same time, efficiency must be optimized. That means we require an integrated approach. The integrated approach is called Lean Six Sigma. Do you all now understand why Lean and Six Sigma are integrated? We need effectiveness. At the same time, we want to be efficient. All right. How all these things evolved? Today, we all talk about Industry 4.0. Am I correct? We all talk about Industry 4.0. What is Industry 4.0? Automation, digitization. I don't want to involve more manpower. I want to automate many of the tasks that is happening in my company. Because, I want to produce faster. I want less errors. I want less human intervention. I will rely on IoT. I will rely on machine learning. I will rely on artificial intelligence. Automation and digitization is now ruling the industry. This is what we call it as Industry 4.0. You know how they have come to this stage? All the industries have come to automation and digitization because they were able to maintain their quality levels at very, very high. Since your quality levels are very high, since your effectiveness is very high, since your business process efficiency is very high, you can now think about automation, think about digitization. So, before automation, your readiness for the important. So, this is called industrial revolution. Long back, quality was considered to be the ability of the craftsman. Quality was considered to be the ability of the craftsman. You want to make a furniture, then you rely on the skill of the carpenter. Today you need a good furniture. Will you rely on a carpenter? No. Today we all rely on, we have, everything, manufactured in the factory. That means, our thinking perspective about the quality is continuously changing, and then accordingly some revolution is also happening the way products are manufactured in the company. That means Industry 1.0, which is called the craftsman skill. Quality was considered to be the skill of the craftsman, and then standardization of the process, You don't have to depend on the skill of the operator if you want for getting a high quality product. You standardize everything, and as a result, quality can be taken care. Industry started understanding that. That period was called Industry 1.0. At the same time, the concept of interchangeable parts also came into reality. And then industries started measuring the characteristics of the product before sending the product to the market. That is nothing but quality control. You check the product features before supplying to your customer. That's called as quality control. They started using gauges, dial gauges, go gauges, no-go gauges. That period is called Industry 2.0. At the same time, Ford also come up with the assembly line concept. You know what is Ford assembly line concept? The operators will be standing in their places, rather the material, the product will be moving against the operator. So as an operator, you don't have to strain much. You don't have to put a lot of effort. You stand comfortably in your place. The product will come to you. Then you work on the product. This is called the Ford assembly line concept. So then later what happened? Somewhere around 1960s, 1950s and 60s, the Japanese industry, particularly a company called Toyota, they learned from the Americans, they learned from Ford production system and suitably converted that Ford production system into a system which can suit Japanese market, because the Americans market was very big. That means mass production was required, but the Japan's market was very small compared to Americans. That means mass production will not be helpful. Maybe you have to rely on batch production. Maybe you have different variety of products. Reduction in batch size and then flexibility was the major requirement as far as the Japan market is concerned. So a company called Toyota, they customized the Ford system into a system which is more suitable to Japan. They named it as Toyota production system. Today we call Toyota production system, or we renamed the Toyota production system as lean manufacturing. You know what is lean manufacturing? Waste elimination. Eliminating inefficiency. And the Japanese, they started, doing very well. Their economy started growing after, the World War II and other things. The Japan was badly hit, but because of all this revolution, the Japanese industry started doing very well in terms of quality, and they started gaining, the lost economy. They started also giving tough competition to the Americans, from whom they actually learned quality. And the American-based company, based company, Motorola, the same time, they wanted to overcome the quality issues. They wanted to overcome the tough competition that were given by the Japanese. So that gave birth to another approach called Six Sigma, right? That is, that Six Sigma was conceptualized at the company, US-based company called Motorola. So these revolutions of having, the lean manufacturing or Toyota production system and Six Sigma, this period somewhere between 1950 to early 1990s, that period is called Industry 3.0. So Industry 3.0 is nothing but effectively solving quality issues or solving all the issues related to effectiveness and inefficiency. People started talking in terms of effectiveness and in terms of efficiency and nothing but the Lean Six Sigma. That period is 3.0. Obviously, if you look at any company, all of them will go through these revolutionary phases. Initially, they will rely on people. Tomorrow, if you start a company startup, initially you will rely on your employee skill, and gradually you will bring some measuring process, isn't it? Performance measures. That means you are now getting into quality control. Then now you are getting into the third stage where you will talk about customer satisfaction, quality, productivity, cycle time reduction, effectiveness, efficiency, inventory level, and all those things you will talk about. That means now your company has matured, Industry 3.0. Now you are super efficient, you are super effective. That means your products are really world class. Now what will you try to do? You will try to automate. You will try to digitize. That is called Industry 4.0. So Industry 4.0 is automation, digitization, robotic process automation and digitization. And for that, you need all these, you use all these technologies, IoT, artificial intelligence, and machine learning. Please note, all the students here, do you want to work in a company which has already entered Industry 4.0? Or do you want to work in a company which has already entered Industry 3.0? Or are you okay to work with companies who are still in the 2.0 revolution? Or are you interested in working in a company Industry 1.0? Please decide. And companies, without going through these phases, they cannot enter into 4.0. Same way, you also, without learning the fundamentals of quality, without knowing quality control, without knowing TPS, Lean and Six Sigma, you cannot enter into industries which are believing in automation and digitization. And trust me, even today, 90% of the industries are in the 3.0 stage only. So your job market will be very, very high in this area. If you really wanted to crack this job market, then you must master, you must know the history of all these things, not only the history, the real fundamentals, principles, and tools and techniques behind TPS, Lean, and Six Sigma. And that is why, we are bringing this flavor to you at the right point of your life. Is that clear to all of you? Yeah. Maybe tomorrow industry 5.0 may happen, but however, any company will go through these phases. Only by crossing 1.0, you can reach 2.0, 3.0, and so on. See here, Toyota production system. Now I will, another 10 minutes, I will talk to all of you about the Lean. So Toyota was a company in 1926. They were into loom work, some kind of government related products they were dealing. So that founder, Sakichi Toyoto, he know there is a big market exists for automotive. So he converted his company into Toyota Motor Corporation. Then in 1950, the nephew of the founder, his name is Eiji Toyoto. He visited Ford. He studied the Ford production system and converted that into Toyota production system. Right? And for conversion, he took the help of quality experts like Taichi Ono and Shigeo Shingo. But with the help of all these professionals, he in fact customized the learnings he had from the Ford production system, and he named it as Toyota production system. And Toyota production system, the fundamental principles of Toyota production system is right sizing the machine and making the machines self-monitoring. As a result, they were able to produce faster. They were able to reduce the cost. They were able to achieve highest levels of quality, and most importantly, with different varieties. That is what nowadays customer wants. Everywhere they want different choices. Car means car should be available in at least 10 different colors. Lot of variety. And TPS, Toyota production system, since it's garnered the global attention, and therefore it was studied by management gurus, and now the Toyota production system is renamed as Lean and Lean manufacturing. So these are the four underlying principles of Toyota production system. First one is philosophy is the foundation. Adding value to people's life is the philosophy. Toyota was strongly believing in that. They just don't want to make money. They really wanted to do business by adding value to people's life through their products and services. That is their first principle. Their principle number 2, the right process will produce right result. Principle number 3, you develop the people and the partners. They will develop, they will take care of your business. Partners are nothing but your suppliers and vendors, right? And principle number 4, systematically solve all problems related to effectiveness, problems related to efficiency. That means the defects and waste, you must, systematically solve. Systematic means fix the problem at the root level. Root cause analysis is important. Not quality control alone is not sufficient. Problem solving is important. And this TPS later become Lean and now successfully adopted. So this is the nephew of the founder. He is the Eiji Toyoto. And this is Taichi Ono, the introducer of the concept of 7 waste. And this is Shigeo Shingo, the introducer of the tool Pokeyoke, right? All of them are lean tools. And look at the Toyota production system. You can understand Toyota production system by seeing it as a house, right? The TPS house. The house is on the philosophy. Then you need stable and standardized process. The left side pillar is just in time. The right side pillar is Jidoka. Jidoka is visualization, self-monitoring. Just in time means no inventory or less inventory, and then produce only when items are required. Keijunka means leveling. Kaizen means changing for the better, or you can call it continuous improvement. And now involve the people and focus on continuous improvement. The result will be highest quality, lowest cost, shortest lead time, empowered employees, best safety, high morale. These are the requirements in any industry. A few questions to you. So what are the 4 guiding principles of TPS? Principle number 1, philosophy is the foundation. What does it mean? Create value to people through your products and services, right? Principle number 2, right process produce right result. Principle number 3, add value by developing your people and partners. Principle number 4, continuously solve problems through root cause analysis. What are the 2 pillars we saw in the TPS? The left side pillar is just in time. The right side pillar is Judoka, which is visualization. So ultimately, lean is all about identification and elimination of wasteful activities. Identification and elimination of wasteful activities. Improving useful activity is Six Sigma. Eliminating wasteful activity is lean. As a result, your manufacturing cost will go down. Many people think that lean is simply cost cutting. Lean is simply eliminating people. No. Lean is process simplification. See here, if you are driving a car in a heavy environment like this, your driving comfort will be at its worst, right? And the car's performance will also be at its worst. You bring the same car, bring the same driver, but change the environment. See here, you are driving in a highway. Now driving comfort will be best. At the same time, car performance will also be best. How we are able to do it? We have not changed the car. We have not changed the employee. We are not eliminating anybody. But we simplified the process. The driving is made simple. As a result, people are able to perform and then produce result. Process simplification is nothing but lean. In order to simplify a process, you must eliminate all unnecessary activities that exist in a process. So lean has several tools: 7 waste, 5S, Kaizen, SMED, which stands for single minute exchange of dice, Kanban, VSM, which stands for value stream mapping, TPM, which stands for total productive maintenance, 3M, which stands for Muda, Mura, and Muri. These are all Japanese words. Muda means elimination of waste. Mura means elimination of unevenness. Muri means elimination of overburdening. So when you combine these two things, lean and Six Sigma, you will achieve quality, and you will achieve quality faster. You will achieve it faster at a lower cost. So lean will reduce your operational cost. Six Sigma will reduce your cost of poor quality. As a result, your profits will improve, operational cost will come down, and that is the main reason we integrate lean and Six Sigma, right? So focus of lean is to reduce waste, reduce defects, reduce variation. Now I want the participants to answer before we go for the debrief. So can you answer this question? What is the focus of lean? Reducing waste or reducing defects or reducing variation? Can you answer this? I need a response. You can type in the chat box. Come on, guys. Come on, what is the focus of lean?
Variation.
No. The focus.
Waste, sir. Waste.
Focus of lean is on waste. You eliminate the waste, right? And focus of, next question, focus of Six Sigma is to reduce defects, reduce waste, or reduce inventory.
Reduce defects.
Very good. Defect reduction is Six Sigma, waste reduction is lean. Beautiful. Now what is that we learned? Six Sigma model, Lean Six Sigma model is the execution of business strategy better than your competitors. Quality is meeting customer requirement consistently. We need numbers. We call them as KPIs and metrics. KPI means key performance indicators. These numbers will help us to monitor and improve the business performance and meet the quality goals. Quality is a function of customer requirement, design requirement, process requirement, and the employee requirement, because the employees are the people who manage and control the process. We need to take care of their requirement. 4 principles of TPS: philosophy, process, people, and problem solving. Eliminate all wasteful activities using lean and prevent defects using Six Sigma. Lean Six Sigma can be used as an operational excellence model to improve quality, reduce cost, and reduce lead time to delivery. So lean tools for the just-in-time and JITOKA, 7 waste case and 5 years value stream mapping, one-piece flow of overall equipment effectiveness, total productive maintenance, okay, single minute exchange of dice, can done, 3M standard work. You don't have to master everything, but start learning them one by one. That is what is called the belt level. Six Sigma tools, Six Sigma Assets do not have its own tools, but it makes use of the existing tools. It is an amalgamation, integration of quality control, project management, problem solving, team management, decision making, communication management, and all these tools integrated are called Six Sigma tools. So use appropriate tools and appropriate methods to correct and prevent the process failures in any organization to produce the business results which the organization wants. And that means the journey is towards operational excellence. So thank you very much, all of you, for your patient listening from for the last 1.5 hours or 2 hours. I really enjoyed all your participation. My further suggestion is, please do continue the same spirit, and then keep the same energy level and keep the same level of interaction in the remaining sessions also, so that you can really become a wonderful yellow belt as an outcome of the program. Right. I stop here, and I am now available for your questions if there are any. Any questions anybody would like to ask me? Come on. Come
Yes,
on.
sir.
Any questions? And also, whenever we are having question answer session, please do switch on your video so that we can also have face-to-face interaction. All of you just come on video for a while. Please switch on your video. We will also take the attendance. Always, every time when I come to the interaction mode, when I stop sharing the screen, please do switch on your video. Another time you can switch off. Yeah, all of you. I can see only Aman and Kumar Yuvraj. How about others? And we need to take one attendance also as part of the course requirement. And some of the students are also watching the session in YouTube channel. And so please, those of you who are in the meeting, please continue staying in the meeting. Otherwise, what happened? There are only limited seats. You may find it difficult to join again. And another thing is, keep subscribed to the channel, so that every time when we actually come live, you get a notification so that you can quickly join. Otherwise, what happened? You may not come to know that session is going on, or some useful information you might miss. Yeah, all of you, please do switch on very fast. You are taking more time because we need to have some 10 minutes tea break also. 11:45, the other trainer will come. Please come on video. Priya madam, you can take the attendance.
Yes, sir, taking attendance.
Yeah, please switch on video, all of you. Still many are not responding. Please do respond. And because, unless and until you respond, how do we know that, you are present? So particularly this is, attendance. Vasant, Sivaprakash, Padlishwaran, Surya, Hemant, Karthika, and many. You need to switch on. Right, Prabhakar sir, you can take.
Sir, I am taking now photo. Just a minute.
Yeah, please. Why don't all of you smile? He's taking a photo. Right. There are 4 screens, so many screens.
Yes, sir. Sir, in the screen 3, I am not getting anyone on video. Students, can you please come on video? So everyone is on mute position. If you come on video, I can have your photo snapshot.
See, every day attendance will be taking, and that will be used as attendance. 2 things are considered as attendance. One thing is you coming on video. The other thing is we'll take your feedback from attendance. A form will be posted every day to fill up. If you are having an issue, that may become a problem. All right.
Second photo, sir.
Thank you all. Go for a tea break and take 10 minutes break and then come back. Sharp 11:50, you will have the defined pace. Always.
Same link, sir.
Same link, same meeting ID, same thing.
Okay, sir.
Come here, Raj. Raj, so bad.
Sir, can we stay in this meeting itself, sir?
Yeah, you can say no problem.
Okay.
निकल जाना आप रेडी
सुमित धोपा काढा सुमित सुमित
खत्म हो गया
எந்த வாடி தயவு செஞ்சு போட சொல்லாது அங்க போட்டதாலே அடிப்படுது
ஏமா
Ravi sir.
Hello, Dr. Ravi. Have you joined?
Join Paniter Ravi sir.
Yeah, hello. Anybody have question? I think there is somebody searching me in the chat box. I'm available now. Sunil, do you have any question to me? Yeah, come on, yellow bells. Are you all available? I wanted to give you some useful tips.
Yes, sir.
Yeah, I want to give all of you some useful tips so that you can really benefit out of the program. So every day I will be conducting a session, and another industry experienced trainer, my friend Dr. Ravi Kumar, he will also be conducting the training program. In order to keep the energy levels high, as well as in order to keep the achieve the expected outcome, you have to be very engaging with the trainer. Whenever see me also asking sometimes some questions, I expect an yes or no. Sometimes I expect you to type something in the chat box. Sometimes I expect you to be on video. Please do fulfill to all those things, like respond to all those things. What happens, sometimes what will happen if you people don't respond, the trainer will lose the momentum and then he will slow down, and then the planned content may not get fully covered. So I really wanted to avoid any disappointments and challenges and the issues in the end. So every time when the trainers are not sharing the screen, my best suggestion is switch on your video and then keep some discussion going on. Right at the time of break or right immediately after the break. For example, you need to speak something. Like maybe you can just ask us some funny questions or whatever, or it can be subject related question, or you can simply ask anything, so that people get a feel of getting connected in the meeting. So with that note, I have pleasure in seeing the other trainer, Dr. S. Ravi Kumar, a good friend of mine. He is also a Six Sigma expert, a black belt, and has a balanced experience. This is very important, right? An industry professional may not know the student's requirement. An academic professional may not know what is happening in the industry. But when we have a mix of both sides, this is what actually required for the students. So Dr. Ravi Kumar has a balanced experience in teaching, training, as well as consulting. So he knows the academic environment. He also knows the industry environment. So he can also be a good fit for your Lean Six Sigma learning. And that is why I have invited him. So the next session is going to be the define phase. How to define a project, how to identify a project, and how to create a project charter. And that will now be explained by Dr. Ravi Kumar. So I hand over the session to Dr. Ravi. Over to Dr. Ravi. Ravi Kumar sir, please unmute yourself. Unmute yourself. Ravi Kumar sir, unmute yourself. Yeah.
Yeah. Thank you, Dr. Siva. Thank you for the introduction. And thank you to meet all you students in this wonderful juncture. of Lean Six Sigma Yellow Belt training program. So since we are very short of time, I will start the session immediately. Madam, Priya Madam, actually my sharing option has been disabled. Could you please enable
Yes,
that?
sir. I'll make you as a co-host, sir.
Okay, madam. So nice to meet all of you. Yes, I believe you have an introduction from Dr. Siva, who is an expert in this particular topic in Six Sigma. Yes, I'm not seen any videos on. Okay, that is a trend of today's students community. Okay, yes, actually I got one guy, Joel. Yes, how are you guys doing today?
Yes, sir. Fine, sir.
Fine. Okay.
How are you, sir?
Yes, fine. Thank you. So nice to meet you. Okay, let us start the session. At least we have one guy responding. That is a great motivation. We also need a motivation, right? In the form of responses. Okay, nice. Let us move into the topic. So we are going to see about the yellow belt define phase. Okay, so before going to the define phase, I want to give a small quote given by Dr. Einstein, Dr. Albert Einstein, who is one of the masterminds for developing the atom bombs, which was used in the Second World War. He said, if I had 60 minutes, that is 1 hour to solve a problem, and if he doesn't solve the problem, he will be killed. Imagine like that. Then in that 60 minutes, Dr. Einstein will spend 55 minutes, that is nearly 90% of the time, to define the problem. So what do you think, Joel, it is? Joel, what do you think it is? Joel, are you there?
Yes, sir. Yes,
So what
sir.
do you think Albert Einstein what do you understood from Albert Einstein's statement?
We have to solve a problem in about a minute, sir.
In 60 minutes. But he
Yes, sir.
says, I will spend 55 minutes for defining the problem. What does it mean? Anybody can say.
He will try to solve the problem, sir.
Okay, definitely he has to solve the problem. If he doesn't solve the problem, he will be murdered.
Yes, sir.
Imagine. But what he says, in that 60 minutes, I will spend 55 minutes to define the problem. What does it mean?
He will try to understand what's the problem, sir.
Yeah, that is absolutely what we are trying to find you. That is, if you find the problem, if you define the problem exactly, then finding the solution is not at all an issue. You can find the solution just like that. That is what Albert Einstein said. He said, man, if you define the problem, if you find the problem exactly what it is, if you find the exact root cause and the problems, you'll be able to solve it easily. So most of the answer for the problems lie in finding it properly, defining it properly. So in Lean Six Sigma DMAC methodology, the first and important phase is define. In define, we are going to find out the problems exactly. Okay. So let us move into the define phase. So this is a short introduction about myself. Dr. Siva told you everything. I had a mixed experience in industry as well as in universities and engineering colleges. Okay. So now we move to the define phase. As said by Dr. Albert Einstein, define is very important in DMAC methodology, also in your life. What I am going to do, you have to define that. So the first and foremost phase, define. What we are going to do in define phase? What is the objective? See, first I am going to identify project of importance. See, there may be 100 problems around me. There may be 50 projects around me. See, in engineering, normally we have to see problems as projects. For example, previously there was a problem in Chennai during the rainy season. What problem it is? Aman. I have another guy called Aman in the video. Aman Kumar. Yes, what problem Chennai experienced during the rainy season? You are not from Chennai, Aman. Unmute yourself.
Sir, please repeat, sir.
Yeah, what problem we faced in the rainy season?
Sir, drainage problem, sir.
Yeah,
Yeah, sir.
lot of drainage problem. Yes, Joel said correct, right? Yeah, drainage problem.
Yes, sir.
Okay, so as a result of that, we had an opportunity to do a project to solve that problem. So poor drainage system is a problem in Chennai during rainy seasons. So you can, the government will take up a project, will do a project to do something for the drainage system. They will try to put a project to solve the drainage issues. So in engineering, we see problems as projects. So first you need to identify the problem which is creating a lot of trouble. You need to identify a problem which is spoiling our career or spoiling our studies or spoiling the entire community or spoiling the production or spoiling the profit. See, you go to a restaurant. If the restaurant food quality is not good, will you go again there, Joel?
No, sir.
No. The quality of the food is spoiling the business. So we can do a project to improve the quality of the food there. So first, you need to identify the project of importance. So that is the first and foremost objective. Yes, Danish, you had a question. Yes, what do you want to ask? Danish. Danish. I think Danish asked a question. He raised the hand. Okay. If he had a question, he can type in the chat box. He has written something. Yes. What is it? Voice is not hearing. Yes, all of you are able to hear your voice. Hear my voice?
Yes, sir.
Yes, sir. Yes, sir.
Danish, I think you have to check your network. Okay, because nearly all of them are able to hear. Out 85 participants are able to hear. Please check your connectivity. So first and foremost thing, we need to identify the problem which is creating a lot of trouble. Rainwater problem is rainwater drainage is causing big trouble in Chennai. So that is the first and foremost project which the Chennai Corporation has to do. So project of importance has to be identified in the defined place. Then understanding the process boundaries, timelines, and customer requirement. Why we need to understand? Okay, I asked Joel. Okay, Joel, which semester are you in? 7th semester? Sorry, 8th semester or 6th semester?
Currently, I'm in 4th semester.
4th semester. Okay. So I gave you, how much time do you have for completing your BE degree course?
Exactly 2 years.
2 years. He just had another 2 years. That is a timeline. So in all kind of projects, see, studying BE is also a project. See, you have timelines. You have timelines to meet out. You cannot study BE for 5 years and get a first class degree. If you want to perform well, if you want to show that you have excelled in that engineering course, you have to finish everything within 4 years. Likewise, when you identify a project, you should understand what is the timeline, how much time do I have to start the project and when to complete this project, when should I start, when should I end. You need to understand the timeline, know the timeline. And the customer requirement. What is the customer requirement? See, when you go to a restaurant, the customer wants a good quantity of food, good quality of food in an ambience environment. Okay, with a nice taste, everything. See, I am going to give the customer a good ambience, but I am giving good quality food. I am also giving good quality of food, but I am giving small quantity. Will the customer be happy? I am saying, man, I am providing air conditioner, lights, good ambience, table, chairs. For that, I am reducing the quantity. Joel, will you accept that biryani?
No, sir.
You'll say, man, other restaurant is paying more, giving more. I will go there. So we need to understand what is the customer requirement. See, I may have different aims and ambitions, but whether does it satisfy my customer requirement? Does it answers my customer need? I should understand that. So when you are doing the project, you must make sure that it accepts, that it understands, that you understand the need of the customer, the requirement of the customer, the necessity of the customer, and start the project. Okay, then process boundaries. See, for example, we are going to do a drainage system in Chennai to remove the excess water during rainy season. Okay, Danish, I think still you are having the problem, right? So man, you restart and join once again. Danish is having the same problem. Madam, could you please check with Dhanush? Okay, and Nitish also is having a similar problem. Okay, please check. Madam, could you please check them? Okay, so we need to understand the process boundaries. So what is the process boundaries? See, for example, Joel wants to do a project. Okay, see, he wants to do a project, integrated project in electronics along with mechanical components. So for that, he needs the help of electronic department. So what he will do, he will write a permission letter from his, get a permission letter from his HOD and get the permission of that particular department, electronics department HOD, and try to access that lab. See, after starting the project only, he knows that he needs the help of computer science department or research department. If he wants to go there without permission, it is very difficult because he is allowed only in electronics and mechanical department. If he wants to go to computer science department and took some research content, he doesn't have permission now. His process boundary ends with the electronics department, mechanical department. He again has to get permission. But in industry, it is not possible. Once you define the boundaries, it is very difficult to overcome that. Once you fix the financial cash allowed for the project, it is difficult to get next permission. So we need to understand what is the boundary, physical boundary within which we work. Okay, so when you are starting the project, you need to understand things. What is the boundaries I am allowed? What are the boundaries I am allowed? Okay, what is the time availability? What is my customer requirement? So you have to understand these things before identifying the problem and understanding the project and starting it. Okay, then only the project will be a valid one. Otherwise, you take it to the project to the general manager or the manager or your guide, he will reject it, saying that, man, your process boundaries are out of scope. Okay, we cannot do that. The timeline is more. If Joel says, sir, I will do a project in 1 year. No. They will say time is 3 months only. Maximum allowed time is 3 months. Finish it within 3 months. Otherwise, do some other projects. Okay, so first you need to identify the project. Then you have to understand the boundaries within which you have to work, the timelines within which you have to work, and your customer requirement. Without understanding the customer requirement, you cannot work. Because the entire company, organization, everybody is working for customer. Whether Hyundai is manufacturing car for the owner, Joel, Hyundai is manufacturing car for the owner.
No, sir.
No, they are manufacturing. Yeah,
Customers.
they are manufacturing for customers like you and me only. If they are not satisfying my requirement, then who will buy that product? You have to understand the customer requirement very carefully. All companies have a customer. You may not know it easily, you may not know it visibly, but if you look into them, if you go to the client list, they will say these are our clients, these are our customers. Okay, now I have identified the project and I have understood the process boundaries, timelines, and customer needs. What's next? I have to put a, see, when you are doing a project, you will be writing a report. You will say it as project report. That is called project charter in DMAC methodology. Project charter. What is a project charter? You will see it in detail in the coming slides. We have a separate topic for that. So project charter is a document which will be like your progress report. So when you when you start from first term, you will have a progress report updating all the subject marks, like, right? Likewise, we have a report card which will have the details about the project, which will have who is responsible for finance, who is responsible for the project progress, who is the project manager. Okay, when we have to start, when we have to end, all these things will be recorded in the project charter. It is like a report, a document. Okay, we have to develop that project charter. You are responsible as a project manager. You will be responsible for developing the project charter. It is a written document which will be updated regularly during the project progress. So these are the 3 objectives. First, you need to identify the project of importance. Then you understand certain basic things. Then you have to develop a document. Okay, that has to be approved. I will speak about that later. Okay, in DMAC methodology, everything is done in a sequential order, step-by-step procedure. So when you go to a laboratory, the teacher, the professor will say, okay, first you have to open the particular tab. Then you load the program. Then you select the GUI. Then you execute it. He will give you a step-by-step procedure, right? In DMAC, that is define, measure, analyze, improve, Lean Six Sigma methodology also, we have a step-by-step procedure. So in order to achieve those objectives, okay, I said 3 objectives earlier, right? In order to achieve those objectives, if you follow these steps, it will be very easier. No need to worry. See, if you go to laboratory, you have a, suppose if you are going to computer science algorithm lab, they would have given you a step-by-step procedure. If you do all those things, everything is done. Or for example, if you have purchased an Android mobile, to start with, they will give you some instruction. Okay, switch on this, switch on that, install this, install that, connect Wi-Fi. They will say this. So if you have done this, what will happen? Automatically, everything will be falling in position. So the phone is ready to be usage. Likewise, to achieve those defined objectives, if you follow the steps, it will be very easier. So let us see what is the step number 1. First, we need to identify projects. How to identify project? I will help you with that in the next topic. Okay. Once you identify the project, you have to select it. You have to select it. Okay. Then once you select the project, you have to write the project charter. That is important. So I have identified the project. Joel can say, sir, I have identified 10 projects. Which project I have to select? Everything looks good to me. I will say, don't worry, Joel. I will guide you. There is a tool to help you to select which project is important. See, the important thing which you have to remember in DMAC methodology in all these 5 phases is everything will be done with the help of analytical method. See, for example, if I am asking Joel, how is the day?
Yes, sir. So
Good. He will say, sometimes he will say good, sometimes he will say bad. Whether I can measure anything about good and bad? No. For example, let us ask another question. Okay, how you have performed in the exam, Joel?
yes, sir. Very well, sir.
Very well. Does it have any clear-cut meaning, specific meaning in that? Whether it means he will score 99 or whether it means he will score 80, it is not understandable. It is not very clear. So in Lean Six Sigma methodology, what we are going to do is we are going to convert everything into numerical values. If Joel says, sir, I will score 99%, then I understand, man, he has done really very good. If saying good and saying 99 is there is a vast difference. You are able to easily understand 99% than good, right? It is more specific. So in DMAC methodology, we are going to convert everything into quantitative thing. Okay, if I ask somebody, okay, go and get some rice, he doesn't know how much rice he has to get. If I say, okay, man, go and get 1.5 kg of rice, then now he understands he has to get only 1.5 kg. This is quantitative. 1.5 is quantitative, measurable, understandable, easily acceptable. But if I say sum, we doesn't know the value of it. So in Lean Six Sigma methodology, we are going to convert everything into quantitative values. So it will be easy for you to select. So that is also the same procedure we are going to do in selection of projects. We have 10 projects in hand. We have identified 10 problems. To solve the 10 problems, we can do 10 projects. Okay, now which project has to be selected? We are going to give them some ranking based on some criteria. Okay, for example, you are going to an interview. They will give rank for academic skills, interpersonal skills, group discussion, okay, then logical thinking, reasoning. They will give marks for every topic, right? Then they will add. So out of 25 students, 10 have scored above 90. Okay, let us select the 10. They have selected 10 students easily. That is how we are going to select the project. I am going to select one project. So I am going to give them some, I have to develop a methodology to convert everything into numbers. Then based on that, I will select the project easily. Okay. So first I am going to identify the projects. So we have a method for that. Then I am going to select the project. Then I am going to finalize the project charter. What is project charter and finalizing the project charter? After writing everything in the project charter, I have to get the approval from my top management, the general manager or the higher management authorities. Then only it will be approved project charter. So these are the 3 steps which you are going to do in defined phase: project identification, project selection, project charter. That is PI, PS, and PC. Project identification PI, project selection PS, project charter PC. Got it? So now we move to step 1. It's okay. So I forgot this, right? See, how to execute these steps? We need some help, right? So we have lot of interesting tools. Don't think these are all physical tools or software tools. Everything is known to you. Project charter is a tool. Cana model is also a tool. SciPAC, that is supplier input process output customer. This is a tool. Pareto chart. See, all of you know how, all of you would have drawn the histogram in your max classes. That is a tool. All of you would have drawn graphs in your laboratory classes. That is a tool. So we are going to use simple tools like that to achieve, to do these 3 steps. That is project identification PI, project selection PS, and project charter PC. To do this 3 steps, we are going to use some tools like this. Prioritization matrix. Okay, critical to quality tree, CTQ tree, affinity diagram. Okay, then run chart. Y is equal to f of x is a small relationship. That will also help you to find out the relationship between the input and the output. Toll gate review. Then QFD, quality functional deployment. See, all these tools are available to, which helps you to achieve those objectives. See, Joel, you are from which department?
I'm from automobile.
Automobile. Okay, if I ask Joel, go ahead and design a car. Hey, sir, I need some tool. He will ask, sir, whether which tool I can use, whether I can use ProE or whether I can use Unigraphics or CATIA, which tool I should use for drafting the model. So likewise, these are all tools, small tools, but very simple ones, not as complicated as CATIA, Unigraphics, or ProE or FEA. Just putting a table itself is a tool in Lean Six Sigma. Prioritization matrix is a table. So every tools which you are seeing in the screen is very simple and easy to understand. But you will have, unfortunately, if you want to learn all of these things, you have to go to the green belt level. Okay. Okay. So now let's move to the last thing. That is, what will you get at the end of the define phase? So earlier, at the end of the define phase, we started with selection of project. Okay. So what is going to be the outcome? What is going to be the output of the define phase? First, we will get a project selected. Out of 10 projects, we would have selected 1 project. Then that project will be converted into a document in the form of a project charter, and it will be approved. What is approved project charter? See, for example, you have written a report. Finally, you have to get the signature from your guide, right? From your supervisor. Then only that report is valid. Likewise, we have to get the approval from the top management. When you are working in the company, your manager or a general manager has to approve that project. Then only you can move, you will be allowed to do that project. So approved project charter. Then high level process map. This will help you to understand what are the various activities happening in the particular company. See, for example, if you want to join engineering colleges, or if you, sorry, for example, if you want to join a company, what will you do? First, you need a basic degree. So for that, you would have written all the exams. Okay, then you should apply for the company. Then you will have an interview process. Then you will first you will have technical interview. Then you will have HR interview. Then everything should be cleared by you. Then you will be able to join this particular job. See, these are all various process. You need to understand this process. Then only you can apply for. You will be recruited. You will be able to join a job. Everything is a process. Completing engineering is a process. Applying is a process. Okay, clearing the technical interview is a process. Everything is a process. So in organization, if you go to any organization, they will have one purchase department, quality department, production department, shipping and logistics department, housekeeping department, HR department, quality department. We need to understand all this process. Then only your project selected will be, you will be able to understand in which department you are going to do the project, what is the process you are going to handle. So for that, you have to develop a high level process map. So at the end of the define phase, you will have a project in your hands, selected project, and you would have developed a document for that, that is called a project charter. And also you will be able to find a high level process map. Okay, now what is the object? Okay, what are the steps in define phase? Any one of you? What are the 3 steps in define phase? I said in acronyms, 3 simple steps in define phase. Yes, anybody? Yes, nobody? Yes, Joel, what are the 3 steps, man?
Project identification,
Yes.
select the project. Third is finalize project charter.
Very good. Project identification, project selection, and project charter. Very good. So first step is project identification. I told I will help you to identify projects, right? Okay, how to identify the project? We will we will use a simple tool there for that. First, we need to identify the project. Then we have to select the project. Then for that, we have some simple methods. Okay, identification of project, selection of project. Okay, for that we have some simple tools and techniques. See, one of the technique is VOC, VOB, and COPQ. Don't think it is some chemical names, some different terminologies. Voice of customer, voice of business, and cost of poor quality. Then finally, we will end up with project charter. Okay, so let us start one by one. How to identify the project? Okay, normally you would have seen in engineering, whatever we start with, we will say what are the different methods to do that job. What are the methods to calculate the power? What are the methods to calculate the efficiency? Like that, in project, in Lean Six Sigma also, in define phase, we have methods to identify the project. Indirectly, we are identifying the problem. As I said earlier, problem means project in engineering. If there is a problem, there is an opportunity to do a project. That is how engineers have to view into things. If there is a problem, if there is a difficulty, if there is a problem, then it is an opportunity for you to do a project there. So first, what are the methods to identify the projects? We have 3 wonderful methods. That is voice of customer analysis. See, for example, you purchase a new Apple phone. Next day, the screen is not displayed properly. There is some problem in the screen. What you will do? You will go to the service station immediately. Planet is a place where Planet is the official store of Apple, right? You will go to the Planet and hand over the phone. There is a problem in the screen. So you are a customer. You have raised your voice against the poor quality of the product, against a particular issue in the product. So voice of the customer will help you to identify the problem. So the research team will find out there is a problem in the display in the Apple mobile phones because many customers are returning the products. You may say that a particular function is not working. You may write to the customer care or you may call the customer care and say that. So the customer feedback can be used as a method to find out the problems. Okay, for example, you are purchasing a Duke bike. You expected a pickup of 100 kilometers, 180 kilometers, but it is just giving 120 only. In the specification, in the manual, it is said you can drive up to 180. So what will you do? You will immediately go to the service center and say, sir, I am not able to ride more than 180, 120, increase my pickup. Or check what is fault in the engine. So in the engine, there may be a problem. So it will be sent to the research department and saying that the bike speed is not up to the level. So they have to boost the specific fuel consumption or increase the acceleration. So the voice of the customer, that is a feedback shared by the customer, will help you to identify the problem. That problems can be converted into projects. Okay. So let me switch on the charger. Just give me one. Okay. So
Voice is not audible, sir.
Sorry. Okay, so first we can identify through voice of the customer. Then we can identify through voice of the business. That is, Joel is running the Msme-Tdc. Khan, mute yourself. Yes, shut up, Khan. Mute yourself. Okay. So now Joel is running a showroom, Mercedes-Benz showroom. Before the pandemic, he was able to sell 50 cars per month. But after pandemic, during the pandemic, his sales was very low. In the past 1 year, he has sold only 100 cars for the entire year. So his business volume, his sales volume is very low. That is the feedback from the business. The profit is very low. So that is a feedback from the business. So through business feedback also, we will be able to identify the projects. So voice of customer will help you to identify the project. Voice of business will also help you to identify the project. See, for example, some of you may be doing small businesses like online businesses or something. So during the pandemic, what happened? Customers are not buying because of poor cash flow. Customers are not buying. So your sales volume is low. So that is your voice of business. So if you are an employee, if you are having some 10 people working for your company, you won't be able to give them salary. So if you want to give salary, you have to get loan from bank. So these are all business problems. These business problems also can be converted into projects in Lean Six Sigma methodology. So first method to identify the project is voice of customer. Second method to identify the project is voice of business. And third one is cost of poor quality. What is this cost of poor quality? Okay, Joel has taken the Apple phone to the Planet showroom. He gave Planet showroom and he gave the phone for repair. In the next day, after purchasing the new Apple mobile, the next day itself his phone screen was having some problem. He returned it. So the Apple showroom executives, they saw it and they say, sir, it is not repairable, so we will replace it. So they gave Joel a new phone. So what does happen there? A poor quality product is being replaced. So actually Apple has lost one mobile phone money in that, because a product was poor, product quality was poor, so they have to give a new phone. They have lost nearly 50,000 rupees because of the poor quality of the product. Phone 1 is repaired, so they have to give phone 2. Phone 2 is given free for Joel. Joel has not paid anything for phone 2. So they have lost 50,000 rupees because of one poor quality product. So cost of poor quality is also a method to identify the projects. So if you are manufacturing a product in poor quality and if the customer is replacing at company's cost, for example, if there is a problem in your air conditioner within 12 months, what you will do? You will raise a complaint and the executives will come and replace the components and do services free of cost. Who is paying that? Who is paying for that particular technician? Who is paying for the component he is replacing? Company is paying for them. So if the product is not functioning, the product supplied is not up to the quality level, then the company has to pay the cost for the service and the warranty. Why the company has to pay? Because the product quality is not up to the level. Because of poor quality performance, they have to provide service. They have to replace the components. That is cost of poor quality. So, see, for example, if you are writing the exams, if a student has failed in the exam, that is poor quality, then whether what he has to do, then what he will do. For example, a particular student has failed in an exam, what he will do? Any one of you? What he will do in the next semester?
Try to get passed
How he will get pass?
by correcting his mistakes.
By correcting the mistake. What he has to do?
Work out more.
Work. Okay. So already he has spent one semester studying the subject. Again, he has to spend time for the same subject, right? Yes or no?
Yes, sir. Yes.
Okay. Apart from that, what he has to do? He has to pay the fee.
Yes,
Yeah?
sir.
Yeah, he has to pay the fees for the subject separately again. Already during the fourth semester, he has paid for that subject. But again, in the fifth semester, for appearing for the higher exam, he has to pay the fees, exam fees once again. He is paying the cost. He has to study more. He has to pay more. He has to go to the exam hall and write the same subject again. So he is spending time, he is spending money, he is spending energy for this poor quality of the subject which he has studied earlier, of the poor quality performance. So previously he has done it poorly. As a result of that, he is spending more time, more money, and more energy on the same product, on the same exam. That is cost of poor quality. So in companies, in industries, through this cost of poor quality, you'll be able to identify problems, and that problems can be converted into projects. So these are the three methods which are available in the DMAC methodology, easiest methodology to identify the projects: voice of customer, voice of business, and cost of poor quality. Okay, voice of customer is topmost important because customers are the boss and their requirements need to be satisfied. If they are not satisfied, nobody is going to buy the products. Very simple. So we need to address the customer issues and solve it immediately. For that, voice of customer has to be given topmost priority, and cost of poor quality is also very important, as well as voice of business. So these three methods will help you to identify the projects. Okay, you may think how we will get projects out of this. Let us see one by one. Okay, so some information about this voice of customer. So reactive, see, you can get the voice of customer through reactive system and proactive systems. See, for example, you purchase a product in Amazon, you order a product in Amazon. See, you receive the product. Even before you using the product, like they will ask feedback about the delivery system, they will ask feedback about the booking system, they will ask our feedback about the packing. Even before you complain about something, they will ask the feedback. Even before you get to the customer care itself, they will call you and ask how is the service. See, for example, if you are staying in a hotel, immediately they will give a form, sir, please give a feedback how the service is. Proactive systems. Even before the customer goes and complains about something, the company or the organization, they will come to you and get a feedback. Proactive systems. Reactive systems. For example, you are staying in a hotel, you are not feeling comfortable, so you call the manager and say, what kind of rooms you have provided. The housekeeping is not good, man. You are complaining. Reactive system. So reactive system is when the customer complains about something, about the product or the service or the system. Proactive systems, the company or the customer care unit take efforts to get the feedback of the customer while the service is in process or while before the service is provided. Okay, so you can use reactive systems or proactive systems to collect the voice of the customer. Okay, so most of the times nowadays all companies are having proactive systems. Even before you start using a product, they are asking a feedback about the product, right? If you purchase in Amazon, immediately you will get a mail. Okay, please give a feedback about the product. So based on the feedback, they are trying to correct themselves. Proactive systems. Reactive system means what Joel did is reactive system. He got a mobile phone, the product was poor, so he returned it to the customer care. to the Planet showroom. That is reactive because he went to the customer and he went to the showroom and complained about that product. Reactive systems. So to identify projects through voice of customer, you can use reactive systems or you can use proactive systems. Okay, then voice of business is, as I already told, that is, suppose if the company, it is purely from company's point of view. If like Joel, if Aman is running a company, his company is having sales is not good, then that is the voice of the business. Then suppose if the cash flow is not good, he is not having sufficient money to purchase raw materials, then that is a problem of the company. So this kind of problems which exist inside the company will be termed as voice of business. Okay, then cost of poor quality. See, the cost of poor quality was derived from cost of quality. See, actually, the cost of quality is classified into cost of good quality and cost of poor quality. So, what is cost of good quality? So, nearly more than 85-90 students are attending this program. See, you have sacrificed your time, you have invested your time, you have invested your energy, you have invested your money on this. So, you are investing cost on improving your quality. By attending this course, by attending this training program, your quality improves in the market, your career quality improves. So you have invested money, you have invested time, you have invested energy to attend this program. That is cost of good quality. By achieving this, your quality improves. So anything which you do, anything which you invest, any money or time or effort to improve the existing product or to improve the existing process in advance, that is called cost of good quality. See, by learning this by attending this particular training, you improve your chance of getting selected in a job interview. If you say, sir, I have a Lean Six Sigma green belt or yellow belt, they will say, okay, you will have some knowledge. People like you are needed because you are unique. Most of the students doesn't have this Lean Six Sigma knowledge. You have this knowledge, so we prefer you, we hire you, they will say. So you are improving your knowledge by investing some money, by investing time, by investing efforts. That is cost of good quality. What is cost of poor quality? A student has failed in a particular subject, so he has to write the exam again, he has to pay money for it, he has to study for it again. That is cost of poor quality. Okay, so this cost of quality can be classified into good as well as poor quality. So we are going to use a cost of poor quality as a method to identify the project. Okay, so for a explanation, I will give you some simple examples of what is cost of good quality and what is cost of poor quality. See, like as I told you, attend a training program, you are attending a online exam, you are attending some online virtual classes. These are all cost of good quality. If you pay for improving your performance or improving your knowledge, which is going to be beneficial for you after completion of BE, for getting a job, everything is cost of good quality. Okay, so in companies, if you go to companies, they will spend time for training. They will give 5 years training, they will give Lean Six Sigma training. See, for training, they have to spend a lot of money, right? See, when they select you, they put you in training for 6 months. 6 months, you don't do any job. You will be just listening in the training classes. They are paying salary for that. Those are all cost of good quality, because if only they train you, you will be able to do the job easily in a successful manner. Cost of good quality. Okay, then what is this cost of poor quality? See, as I told, all this cost, preventive cost, all this comes under the cost of good quality. For example, that is training programs. Okay, everything comes under the cost of good quality. Okay, then ISO auditings, all these auditings, everything comes under the cost of good quality. Then what is this cost of poor quality? See, internal, in the cost of poor quality can be classified into internal as well as external failure cost. What is this internal and external failure cost? See, for example, as I said earlier, Joel has a Mercedes-Benz showroom. Okay, so during inspection, Joel found out that one of the car display was not working properly before selling to the customer. So what will you do, Joel? What will you do, Joel? What will you do in that case?
Sir, will make fix that cost.
Yes, Joel will immediately replace it with a new component and he will set right and show it is as good as it was. So this is an internal failure. That is, even before the product was sold to customer, that car was sold to customer, Joel find out that failure, okay, and he replaced it internally. Because of that also, Joel lost some 10,000 rupees. The cost of that particular dial display was 10,000 rupees, but Joel was on the safer side. He replaced it with some new one and he lost the money for that. But the failure is purely internal. Customer doesn't receive a poor quality product. So if you are able to find out a failure before the product goes to the customer hands, that is called internal failure. For example, Joel has not identified that failure, that problem. I got that car. I got that Mercedes E-Class car. Next day, I found that the dashboard dial is not working. I immediately will go to Joel showroom and I will scold him. What kind of car you are selling, man? You people are useless. You are selling me useless cars. You are giving me wrong products. I will complain it. Then I will write to the customer care. I will write to everybody else and I will say, my friends, man, this showroom is not selling good products. See, the entire reputation is spoiled. This is an external failure. When the product reaches the customer hands and if the customer finds a fault, and if you came to know about the fault of the product through customer complaint, that is an external failure. The cost of external failure is worst, because apart from replacing the product, the reputation is also lost. If you are able to identify a failure in the organization before the product reaches the customer hands, you are saved 50%, because that is also a failure, but at least your reputation is not spoiled. But when the product reaches the customer hands, when the product is in the customer hands, and if the customer complains about the poor performance, that is an external failure. Okay, so you will be able to identify projects through these two methods of the cost of poor quality. That is internal failure also, you'll be able to identify the problems and you can do projects to rectify it. External failure also, you can identify through external failures also, you can identify projects and do projects to rectify it. So many examples are available. Okay, so that is why you can see there is a separate section called testing in software companies. What they do in testing, they will try to find out the failures in that particular software. So if they find any failures, they can correct it even before it goes to the customer end. So internal failures will give a chance to correct yourself through a project. But external failures, the loss is grave. Yet sometimes the external failures will be posted in the medias, in Facebook, WhatsApp, Twitter, and TV channels, newspapers. Then imagine the loss. Your reputation is lost. It is very difficult to regain it. So to identify a project, you can use the voice of customer, voice of business, and cost of poor quality. Okay, if you invest in cost of good quality, the cost of poor quality will come down gradually. So if you invest more in good quality, the cost of poor quality will come down automatically. What is cost of good quality? Attending training, conducting inspections. All these things will help you to reduce the cost of poor quality. See, for example, if two students are going to interview, one of them has invested time, money, and effort in Lean Six Sigma training program. Okay, so he has invested money in cost of good quality. Another student has not studied this Lean Six Sigma training program. So when they go for the interview, the chances of getting rejected is more for a student who has not attended this training. So this student will have more chance of getting selected. So this cost of good quality automatically improves your performance and reduces the chance of poor performance. So automatically the cost of poor quality comes down. Okay, so when you invest more time, money, and effort in good quality activities, it will reduce the poor performance chances. Okay, that is there is no need for you to prepare for another interview. For example, because of Lean Six Sigma Yellow Belt, you get a placement in the interview. So you can be free. There is no need to prepare for another interview. But the student who has not attended this training, he may fail in that particular interview. As a result of that, he has to prepare for another interview. He has to spend more time, more money, and more effort on the next interview. So see, the cost of poor quality is reduced for the student who has attended this training. If you invest in cost of good quality, your cost of poor quality will come down, will reduce. Okay, that is the benefit of the cost of good quality. Okay, now it's time for me to ask question. Okay, what are the 3 methods to identify the projects? Any one of you? What are the 3 methods? Joel, at least you can say. Is Joel there?
Yes, sir. I'm there.
Yes. What are the 3 methods to identify projects?
Title,
Sir, center.
3 methods, man.
POC analysis, BOB analysis, COPQ analysis.
Sorry.
BOC analysis,
Okay.
BOB analysis,
Okay.
COPQ analysis.
Very good. VOC, VOB, and COPQ. That is voice of customer, voice of business, and cost of poor quality. Okay. These 3 methods will help you to identify the project. Okay. Now, I have a simple question for you. எத்தனை மணிக்கு உங்களுக்கு க்ளீன் பண்ணணும்? Okay, so now I have a question for you. Joel, could you read the question?
Yes, sir. If a customer segment complains about a delay in responding to the queries, a metric that can be used to track performance is.
Yes, what is the answer, Joel? See.
Sir.
Yes, try.
The response time.
Yes, very good, Joel. Response time. See, for example, you go to a customer section. They are making you wait for 15 minutes to ask what has happened. So the response time was more, right? See, I am asking a question, but many students are not answering. So the response time is more. I want the response immediately. So if the response time is more, what I will think? I will think that none of the students doesn't know the answer. So when you call the customer care, if they ask you to wait for 10 minutes, you will scold the customer care, right? You will say, man, what kind of service you are providing? The response time is more. Reduce the response time. Keep it within 1 minute. I cannot wait this much on the line. Okay, very good, Joel. Okay. Joel, could you read the next question?
A customer segment complains about a longer transaction, a metric that can be used to track performances.
Yes. What could be the answer?
Transaction.
Yes, you go to a bank. Suppose you are waiting in the queue to, for example, you want to deposit 1 lakh rupees. They make you wait in the queue for 1 hour. You will say your transaction time is more. Please reduce it. So here metric means a measurement, a data, which will help you to track the performance. So you say, sir, ICICI transaction time is 15 minutes only, but Indian Bank transaction time is 1 hour. So reduce your transaction time. You will say that, right? So this is also one metric. Okay. Anyone? Okay, Joel, last one.
Dash comes from within the business. Dash is provided by the customer.
Yes. Joel, you can give the answer. Which comes from the business? I said with you as an I, which comes from the business? VO?
B.
Yes,
B, sir. B.
Yes, very good, very good. VOB comes from the business. What is provided by the customer?
BOC.
Very good. VOB comes from the business. That is voice of the business comes from the within the business. VOC, voice of customer, is provided by the customer. Very good. Okay, now let us move to the next topic. More number of questions. Okay. So I have a simple, okay. This, apart from this, there is another important simple technique called brainstorming. That will also help you to identify the projects. Brainstorming. What is brainstorming? That is, I call 10 experts from that particular field who are connected to that field. Okay. See, for example, I will take 10 from your classroom now and ask, what kind of facilities, what kind of job do you need? I can ask you. You will say, or what kind of problems you are facing in the classroom? I will ask you. Then you will say the problems one by one. You may say, sir, we need projector, we need smart classrooms. Okay, you can say, sir, we need to go for industrial visit. We need internships. We need industrial projects. You can say your requirement. You can say the problems. Okay, you can say what you need. As a customer, you may say what you need. Okay, as a business, as a business operational executive, you will say what are the problems existing in the business. For example, if Joel is, as I told, Joel is running that Mercedes-Benz showroom. Okay, he is having some 25 staff for him. He is having 25 executives working for him. Okay, he wants to improve the sales. The sales is down. So he can ask, what is the problem with the sales? Then the sales team will say, sir, the customers are expecting more. The customers are not happy with the service. The customers are not happy with the particular engine performance. They can give more informations. They can say problems which are existing in their site. So that can also help you to identify problems. That can also help you to identify problems. Okay, so that brainstorming session will also help you to identify problems, and through that also you can identify projects. So when you are conducting brainstorming, you must make sure only people who are connected with the particular organization, particular problem should present there. Okay, Joel should not call somebody from a nearby company to find out the problems until and unless they are a consultant. You can have some consultants. Okay, so you need to discuss with people who are connected with your company, who are investing in your company, or who are doing operations for your company, or who are running productions, or who are running sales, or who are running executives, marketing for your company. Then they will be able to explain the problems from their side. So that problems can be identified, and through that projects can be done. Okay, this is one method, brainstorming. Okay, so I will explain this later. Okay, now I believe you are able to understand the project identification process in the define phase, project identification process. Okay, so any questions or any doubts do you have in your mind regarding project identification? Yes, Joel, you and your team, do you have any questions? You can post it in the chat box, or if you have no questions, you can simply type yes in the chat box. If you have no questions, type yes in the chat box. Guys, whether you have questions or not. Joel? I got one response from Joel. Yes, you are able to understand. Kumar, no questions. Thank you. Okay. Yes, many students have responded. Very good. So you are able to understand, right? Okay, good. Okay, good. Now we move to the next step, project selection. Okay. Now I have identified 10 projects. Okay, now I have identified 10 projects from voice of 5 from voice of customer, 3 from voice of business, and 2 from cost of poor quality. See, just for example, I am saying this. Okay, which project I have to do? I have to select the project, right? Which one I have to do? For that, we have a simple tool called Pareto chart to help us. What is this Pareto chart? How to use it? Okay, we will see that. We will see what is a Pareto chart. What is the role of Pareto chart here? Whether we can use a Pareto chart here because it exists? No. It must have a role here. How to draw a Pareto chart? And what are the types of Pareto charts available? You will see that. See, this is about the Pareto chart. He was the man who developed Pareto chart, Wilfredo Pareto, an Italian. Okay, so he developed in 1896, but it was used by father of total quality management. Sorry, one of the main pioneers of total quality management, Joseph Juran. You would have studied about Joseph Juran in total quality management, or you will study. He was the one who used this Pareto chart in quality improvisation, quality improvement methods for continuous improvement. So this Wilfred Pareto developed this in 18th century, in 1896, and it was used by Joseph Juran in 1986. Okay, after that it was being regularly used in all industries to identify the problems which is having more impact, okay, or to select the projects which will be more beneficial. See, for example, if Joel has 10 projects in his company, he will choose the project which is going to give him more money or which is going to be more beneficial for him, right? He won't do any project which is not going to help him at all. Okay, so Joel is going to select a project which is more beneficial to the company. So we are going to use that Pareto chart to find out which project is more beneficial. Okay, now let us see what is a Pareto chart. See, this Pareto chart, you have 3 axes. Okay, one is a x-axis. Okay, another one is a left-hand side y-axis, another right-hand side y-axis. On the x-axis, you have the type of problems or type of defects or the projects which you have to choose. Okay, so here we have type of problems described. For example, I have a data from a garment industry. I have put the data here. Defective button, stitching defects, loose thread. These are all type of defects. Okay, type of defects means some problems. See, on the left hand side y-axis, you have the number of the count of defects. That is how many defects it occurs. Okay, stitching defect, 200 numbers. On the right hand side of the y-axis, you have the percentage of defects. So you have to remember you have 3 data. One is the attribute data. That is on the x-axis, you will just write the attribute data. That is the type of defects, the type of problems alone. No numerical values should be written in the x-axis. On the left hand side y-axis, you have to just write only the number of defects, only numbers. On the right hand side y-axis, just follow the cursor. You have to write only the percentage. The percentage will be maximum from 0 to 100. Okay, what does this Pareto chart says? What does it indicate? See, Pareto chart says 80% of poor performance is caused by 20% of problems. Do you understand this? See, for example, if you take any classroom environment, for example, I am handling mechanical students for quite a long time. I know if there are 60 students in a mechanical classroom, 20 students will be 10 to 15 students will be absolutely brilliant. They'll be listening classes, they will be submitting assignments, they will write the exams correctly, they will listen, they'll be very attentive. Another 30 to 40 students, they will be average. Okay, another 10 to 15 students, they will be spoilers of the class. They will do all kinds of mischievous in the classroom. So this 20% of students will create 80% of indisciplinary activities in the college. Do you have, all of you agree with me? I believe. Do you know that? You know that, right? So 20% of students in the classroom, they will create 80% of the problems. That logic is being used there. That is 20% of this defects causes 80% of loss, 80% of poor performance, nearly 80% of quality issues. That is why it is called as 80-20 rule. That is 80% of loss may be created by 20% of problem. So if you find out that 20% of the problem and solve it, your performance may improve by 80%, may improve by 80%. So Wilfred Pareto chart helps you to identify which 20% of problem is causing you 80% of loss. You may have 10 problems, but not all the problems are causing you grave issues. Only 2 or 3 problems is causing you so much loss. We have to identify that. Pareto chart will help you to do that. So in Pareto chart, you have 3 data on the 3 axes: x-axis, y-axis, right-hand side, left-hand side, y-axis. And inside the chart, you have another line that is called the cumulative percentage line. Cumulative percentage line. We will see that in the next 2-3 slides. So in the x-axis, you will have attribute data. That is, attribute data means word-wise data, text data. It will be types of defects or types of losses or types of problems. On the left-hand side, only numerical values. On the right-hand side, only percentage. Okay. So let us see one by one. So to understand the Pareto chart, we have a small example. Okay. So in this, we did a project in the Coimbatore garment industry, and they have a problem. The problem is given in the bottom table: defective buttons. See, in 30 days, they have nearly lost 4,92,000 rupees because of these defects. What are the defects? Defective button, loose thread, misaligned fabric, fabric strain, stitching defects, hemming defects, coloring errors. These defect causes nearly 4,92,000 rupees for them in the last 30 days. So they gave us a project to find out which loss is creating more problem for them, which loss is creating more loss for them. Okay, we did a Pareto chart and we gave the information. See, first you need to develop a table. If it has to be done manually, we have to develop a table. See, on the left hand side, what is given from the company was written: defective count, defective defects and defective count. Okay, type of defects and the defective count. Then we arrange it in the ascending descending order, that is from the highest to the lowest. The second, third and fourth column, you can see we arranged everything in the descending order from the highest to the lowest. Highest is the defective button, next highest is the stitching defects, loose thread, fabric, and so on. Once you arrange everything in the descending order, you have to calculate the defective percentage of each defect. For example, total defect is 492. So 217 divided by 492 into 100 will give the defects or defective, will give the defective percentage of defect button. Then stitching defects, 1112 divided by 492 into 100. So 228. Likewise, I calculated the defects for all, defective percentage for all defects. So first you have to arrange the data in a descending order, that is from highest to the lowest. Then I calculate the defective percentage for each defects. Then I calculated the cumulative percentage. How I calculated the cumulative percentage? That is, first defect is 44.1. For the next cumulative percentage, I added this 441 with the 22.8. You have to follow me closely. 44.1 with 22.8 will give you 66.9. 66.9 plus 13.6 will give 80.5. So the third cumulative percentage is 80.5. Then 80.5 plus 8.7, 89.2. 89.2 plus 4.7, 93.9. 93.9 plus 3.7, 97.6. So likewise, I calculated the cumulative percentage. First, I arranged everything in descending order. Then I calculated the defect percentage for each defects. Then I calculated the cumulative percentage by adding the percentage along with the previous one. Okay, so now I got a table. Now what I'm going to do is I'm going to plot this table in the graph. That is very simple, right? So what I did, so you can see defective button. What is the count? 21 numbers. Percentage is 44.1. What is the cumulative percentage? 44.1. Same. Stitching defects. What is the percentage? 1112. What is the, sorry, what is the numbers of stitching defects? 1112. What is the percentage? 22.8. What is the cumulative percentage? 66.9. Loose thread. What are the numbers? 67. What is the percentage of defect? 13.6. What is the cumulative percentage? 80.5. Okay, now I have written everything in the table below the graph sheet. Now what I'm going to do is I'm going to plot it in the graph in the form of a histogram bar. Okay, so defective button, how many numbers? 217. Okay, I put a bar, histogram bar. Stitching defects, how many numbers? 1112. I put a histogram bar. What about the loose thread? 67. Hemming defects, 43. Misaligned fabric stains, 23. Misaligned fabric, 18. Coloring errors, 12. I have put everything in the form of a histogram. Okay, now I can check the percentage. See, for defective button, the count is 217. The percentage is 44.1. Stitching defects, the count is 1112. The percentage is 22.8. So it matches, it synchronizes. So no problem. So now I have plotted the three datas. That is the attribute data on the x-axis, the number of count on the y-axis, and the percentage of defects on the right-hand side y-axis. Any doubts in this? Anybody? Joel, are you able to understand?
Yes, sir.
Okay. So now we are going to plot this cumulative line. That is very important. You have to follow me closely. This blue color line, this is called the cumulative percentage line. See, first, what is the cumulative percentage of defective button? Joel, what is the cumulative percentage of defective button?
So the cumulative was 44.1, sir.
1. Very good. 44.1. So I put the plot, I put the point here. What is the cumulative percentage for stitching defects?
Sir, 66.9, sir.
Very good. Next point is here, 66.9. What is the cumulative for the loose thread?
80.5, sir.
80.5. What is the fourth point? Fourth cumulative percentage?
89.9.
What is the fifth one?
93.9.
Seventh? Sorry, sixth?
97.6.
Last one is 100.
100.
So, okay, now what Joel has done is he has plotted 7 points and he can connect it using a curve. This is a cumulative percentage line. Okay, so we have plotted the cumulative points in the graph with the respective percentages, and we have connected that line. This is a cumulative percentage line. Okay, what do you infer from this graph? What do you infer from this graph? See, we have 7 defects here. Whether all the defects are causing lot of losses, or whether there are any specific 2 or 3 defects causing lot of losses.
Only 2, 3, sir.
What are they? Any idea?
Defective button and stitching.
Defective button, stitching defects, and loose threads.
Loose threads.
Yes, if you take these 3 defects, they are causing 80% of loss. Can you imagine? Out of 7, only these 3 are causing 80% loss. So instead of focusing on all the 7 problems, say, for example, Abhishek is running this garment company. So instead of focusing on all the 7 problems, Abhishek can focus only on these 3 problems. He can do project to solve these 3 problems, because if he solve these 3 problems, how much there is an improvement in the performance? How much the performance increases? How much? You can see in the cumulative percentage, how much?
80.
Yes. If he solves this 3 problem, his mark is 80.5. Earlier, the guy was scoring fail marks, but he has 10 problems. He identified and solved only 3 problems in his career, in his life. He scored 80% marks in the exam. That is how we can say. So if you identify 3 important, mostly occurring defects and solve it, your performance improves by nearly 80%. Your performance may improve nearly by 80%. So instead of focusing on all the problems, Joel has identified 15 problems in his organization, in his company. His Mercedes-Benz showroom has 15 problems. Instead of focusing on all the 15, if he focuses on only 2 or 3, it will be easy for him. And apart from that, the performance also improves by nearly 80%. It may. That is how this Pareto chart helps you to identify the project. Sorry, select the project. Don't select all the projects hastily. Select based on this kind of tools. Now, nobody can object you. If you put a Pareto chart and post it in your manager table, sir, this is how I selected the project. Your manager will appreciate you and he will say, it's a wonderful method, man. It is very appealing. It is very nice. So you can go ahead with the project to the next stage. So this Pareto chart will help you to identify problems easily. Which project you have to select. For which problem you have to do project. You can use this Pareto chart. Identifying the defects or identifying the problems which is causing grave loss to the company is how this Pareto chart helps you. Okay, understood? Yes or no?
Yes, sir.
Okay, so this Pareto chart will help you to identify the project which is causing more trouble. And if you solve it, your performance may improve by 80 to 90%. It may. Okay, depending upon the organization and the type of industry you are working with it. So what is the role of this Pareto chart in our project? It helps you to identify the critical defects. Say out of 8 defects, 7 defects, Joel has identified 3 defects as a critical defects. Joel will focus only on that. So it helps you to focus on solving that particular defects and improving his efforts. So his team, for his team, there is no need to focus on all the 7 defects. His team can focus only on 3 defects, leave the 4. Because if you work on the 3, our performance improves by 80%. That is the role of this Pareto in this Lean Six Sigma project. So you have 10, 15 problems. Which one I have to choose? Which one I have to prioritize? Which one I have to look into first? This Pareto chart will help you to prioritize things. So it helps you to identify the major defects which is causing a lot of trouble and helps your team to focus on a particular area instead of focusing on all the 10, 15 problems, and helps you to prioritize which problem you have to attend first. So you may have a lot of problems to work into, but if you use Pareto, you will know which project you have to work, which problem you have to attend first. Okay, in spite of all these wonderful advantages, Pareto will having some problems. What problems does Pareto has? See, you are choosing the project based on the number of times that particular defect occurs. See, for example, Joel is having a Duke or having a Royal Classic Enfield Bullet 500cc Desert Storm. He used to go in bumpy roads. His road is his travel to college is a bumpy road. So his his speedometer cable get disconnected frequently. Every monthly once he has to replace it. So for 1 year he would have replaced 12 cables. But on the 13th month, his engine is giving some problem. Okay, now Joel, you have to answer. Which problem is more critical, engine problem or speedometer cable problem?
Engine problem.
But engine problem occurs only once. Speedometer cable problem occurs 13 times a year. We are choosing problems based on number of times it occurs, right? But
Yes,
but speedometer cable problem is not a major one when compared to engine problem.
yes, sir. That's my.
Yeah, Joel will give importance to engine problem because if engine is a problem, you cannot run the vehicle. So this Pareto chart, which helps you to identify problems based on number of times it occurs, is a drawback. So if you are going to choose the problem based on number of times, then that is a disadvantage. If he is going to solve only the speedometer cables, not the engine problem, as per our basic Pareto, Joel is going to solve only the speedometer cable problem. He is not going to look into engine problem. See, what will be the effect? The vehicle itself will not run. So that is a disadvantage, because what we did, we chose the project based on number of times it occurs. The first 3 problem occurs more times. Speedometer cable occur more times. So I will choose speedometer cable project. No, that is not going to be a success if you do it. So to clear that, you have another 2 types of Pareto. to overcome that defect. See, in the Android phone, earlier they released one version of Android. Then there will be some problem in that version. After 1 year, they will release another Android version, Android 7, Android 8, Android 9. So it is improvised versions, right? Likewise, we have other types of Pareto chart to overcome this advantage. Instead of selecting the speedometer cable problem, you have to select the engine problem. Then only your system will run properly. Your losses will be less. To do that, you have another types of Pareto called weighted Pareto, stratified Pareto, before after Pareto. These Pareto charts will help you to choose the right projects based on the loss which it creates. Engine problem is more loss. So this kind of Pareto charts will help you to choose the right problems and solve that. Okay, to learn more about this, you have to work with the green belt program, green belt training programs. Okay. So now I understand you would have known about this Pareto chart. Yes, Joel, could you read this
80
question?
by 20.
Pareto analysis, also known by 80 by 20 rule. You are so proactive, man. Even before I ask the question, you answer it. Okay, let us answer this one. Yes, Joel, give a try. Or anybody else, if you want to give a try, you read. Anybody else? Nobody else? Yes, someone of you can give a try. Yes, we have wonderful names, Silambarasan. Yes. Lokesh. Anybody else can give a try.
CT of the problems being caused by 20% of the factor.
Yeah, Pareto concept refers to 80% of the problems are caused by 20% of the factors. Very good. Very good. Very good. Excellent. So you people are following it closely, right? Okay. Now we have completed 2 steps in the define phase. Project identification. We used VOC, VOB and COPQ for project identification, and we used Pareto for project selection. Now, okay, let us leave this question. Now we move to the third important step, project charter. As I said something about this project charter. What is that? When we in the introduction, I said something about project charter. What is that? It is like a, yes, it is like a report. Okay. So it is like a report which you write during the project in the colleges. So in the report, you will be having aim, objective, who are your team members, right? So if you are writing a project report, you will have the contents. What is the aim of the project? What is the objective? Who are the team members? What is the project cost? You will have data like that. Likewise, in project charter, we are going to have 6 important elements. One is business case. We will see what is business case. Then problem statement. Okay, we have to write the problem in a certain format. Then goal statement. Then scope statement, timeline, team members. We will see it one by one. Okay, what is this business case? See, for example, if Joel is going to develop a project, okay, he has identified a problem and he has selected the problem. He is going to present to the general manager. The general manager won't be interested what the project is, how the project is going to be done. He will ask what kind of benefit that project is going to give to my company. Okay, so Joel has to say, sir, that we are experiencing this much problem. Because of this problem, we are losing this much money. To identify only, I am going to do this project. So that is what the business case explains. It will describe why this project is important to the company. Because the general manager is interested in any project which is important to the company. Okay, he will say, okay, how this project is important to my organization, how this project is important to my industry. If you say that we are experiencing 1 crore loss per year, sir, to avoid that, we are doing this project. Then he will say, okay, you will save me 1 crore rupees per year. Then I will give approval. That is what the general manager is more concerned about. So in the project report, the first component which you have to write is business case. The business case has to clearly explain why this project is important to that particular company. Yes, any one of you, could you please read example number 1? Yes,
From-
guys, come on. Yes, sir.
From 6/5/2017 to 6/12/2018, ABC has experienced a increase in operating cost. ABC constructions with the target of 0.5. This increase of 22.5% has led to COPQ of $253.
Okay. So here in the business case, during that particular period, that company has losing money through the operating cost. What is the operating cost? See, for example, earlier Joel was running the company at a monthly expenses of 1 lakh rupees. Now Joel company needs at least 1.5 lakh per month. Earlier 1 lakh, now for electricity, staff, every salary, everything. So his operating cost has increased by nearly 50,000 rupees. That is a loss. So if Joel staff is coming and saying, sir, we are doing a project to reduce the operation cost, Joel will definitely put the signature. Yes, please do it immediately. Likewise, your project must explain why it is very important to the organization, how much money it is going to save. Okay, that is a business case. Then problem statement. First, you have to write the business statement. Then you have to write the problem statement. How much pain is being experienced because of that problem? Okay, so I will read this. The last 6 months, 20% of our repeat customers were late by over 60 days. For example, Joel has many customers. Many customers are not paying for the spares. Okay, instead of paying on 15 days, they are paying after 60 days. So what will happen is company will not have sufficient cash flow. He needs at least 1.5 lakh rupees per month. But because since the customers are paying late, there is a shortage in the cash flow. He is getting only 75,000 per month. So there is a problem in operating. So in the problem statement, you have to write about the pain which the organization is experiencing because of that particular problem. Since the customers are paying late, we have a problem in the cash flow and we are not able to purchase the raw materials. We are not able to pay the salary. So the workers' efficiency are less. So we are not able to service the existing customers properly. You have to write the problem and the pain experienced because of that problem clearly. Okay, so first business case, second problem statement, then goal statement. See, the goal statement must follow these 5 factors. Specific. What is specific? You have to mention everything in numericals, measurable. It must be a measurable parameter, measurable data. See, for example, you can measure the temperature, right? You can measure the pressure. Likewise, you have to put measurable parameters. Then it must be achievable. See, for example, if one of a student in a class says, okay, this time I have scored 40, next time I will go score 99. It is not achievable all the times. If you say, sir, this time I have scored only 25 marks in GATE, next time I will score 99.9. Is it not achievable immediately? So you have to fix only achievable goals, not imaginary goals. Then relevant. It must be relevant to the organization, relevant to the project. Then time bound, always time bound. Timeline must be there. When you are going to start, when you are going to finish. Yes, Joel, read the example.
Increase scope employee motivation survey scores apart from the current 42% to 70%. Improvement by end of third quarter 2017 completion date.
See, here there is an statement, goal statement. The goal statement says our employee motivation scores. What is going to do? They are going to increase the employee motivation scores. Very specific. From what is the current value? From 42%. It is very specific, from 42% to 70%. If they say from 42 to 100%, that is not achievable. So they are improving the employee scores from 42% to 70%, which is achievable. And it is also relevant to the organization. How? If they improve the employee scores, The employees will work with a lot of motivation, enthusiasm. Okay. And as a result of that, the productivity will improve. If the employees are motivated, what will you do? If you are an employee and you are motivated by cash awards and you are encouraged and motivated by incentives, you will work more. You will work with the more commitment to the company. As a result of that, the production will improve. So if you want to increase the employee productivity from 40 to 70%, see, the goal is to improve the employee motivation from 42 to 70% by the end of third quarter, from July to September. The starting date and the end date is given. You start from July 1st and complete it within September 30th. And by the time, you have to improve the employee motivation in the organization from 40 to 70%. So if you want to fix a goal, the goal must be very specific and it must be a measurable data, not an attribute data, not from bad to good. You cannot say I will improve the employee satisfaction from bad to good. I have to say I will improve the employee satisfaction from 42 to 70%. I will improve my mark from 50 to 90. You can be very specific. You cannot give I will improve my marks from bad to good. You cannot say like that in goal statement. You have to give numbers from 40 to 70%. And also you have to give time. I will reach the marks from within the next 60 days or next 90 days. You have to give time bound values. So first you start with business statement, then problem statement, then goal statement. And after that, you have to provide scope statement. What is a scope? It is very important. See, we should know our physical boundaries. For example, if you are going to do a project, see, for example, Tamil Nadu government wants to construct a dam project. See, if they want to construct a road, there is no need for them to get permission from central government. If they want to construct a dam, they have to get permission from the central government. So they need to get those approvals earlier. So their scope is limited to certain projects. Their scope is limited to certain ideas. See, for example, if they want to tax a new product, whether they can do it, they cannot tax any product because the central government is controlling the taxations. It is not in their scope. See, for example, Tamil Nadu government want to improve their revenue. So whether they can say that we will improve the tax of the products, it is not in their scope. The tax matters are controlled by the central government. They can improve the revenue through increasing the bus fares, by increasing the electricity bill, by increasing the other commodities like milk, rice and all. But they cannot increase the tax on the product. If the central government wants, they can increase the tax on the products. The scope of Tamil Nadu government is limited to certain areas. See, likewise, if you want to do a project, just a moment. See, if you want to do a project, you should know what are the boundaries you can work within. See, for example, I am doing a project in my, I want to do a project in a company. The company will have 10 divisions, starting from production, okay, research and development, design, then new product development, then quality, transportation and logistics, then training and development, HR, purchase department. You have 10 departments. So when I start the project, I must very clear in the project report, in the project charter, which department I will have control over, which departments I can get data from. I have to include, okay, I want data from purchase department regarding this purchase. I want the research department staff also to provide some information. Okay, I have to get some information from the quality department. I have to define my boundaries in which areas, in which departments I can get data, which department staff should help me. I have to put everything in the report. That is called scope. Okay, I cannot go beyond that scope. Okay, research department will say, well, okay, sir, we can give this much data. Other data are very confidential. We cannot give it. So I have to complete it within that scope. I cannot overlook that. See, for example, take a police inspector. he will have his boundary. Okay, he cannot go and arrest somebody else who is in another boundary. For example, the inspector in Tambaram cannot go to T Nagar and arrest a guy. He has to approach that particular police station inspector only. His scope is limited to Tambaram and Krompat and Saida up to Pallavaram only. After that, if he has any judicial issues, he has to contact that particular inspector and get the things done. His scope is limited. His physical boundary is limited to this Tambaram area only. His physical boundary is limited to Krompat area, sorry, Coimbatore area only. So, likewise, the scope will be defined in the project charter. You cannot go beyond the scope. If you want to go beyond the scope, you have to get the approval once again. Apart from that, the account finance, you will get approval for a finance. In the you will say how much money you need for that. Okay, to complete this project, you may need at least 1 million rupees or 1 lakh rupees or 2 lakh rupees. So everything should be clearly mentioned. What is in your scope, what is not in your scope. Okay. So the scope statement is very important. Then timeline. As I said, you have to give the start date and end date. Okay. Define phase when you are going to start, measure when you are going to analyze, when, improve when you are going to start, when you are going to end, control when you are going to start, when you end. So all this starting and ending dates must be provided. You must be very specific. So you start with business case, you write the problem statement, you write the goal statement, then scope statement, then the timeline, then finally your team members. Whenever you are doing project, you will say, okay, we will have 2 members from this team, 2 members from that team. Likewise, we need team from different people. For example, if I'm going to do a project in design, then I must have some people from design, somebody from quality, somebody from product development, somebody from research. I can select the team members based on their skill set and based on their knowledge and expertise. Okay, so I need to select team members, but mostly the team members must be aware of the project and the problem which they are going to solve, is they are going to work. So generally, we will have the stakeholders. Who are the key stakeholders? We use this word stakeholders regularly. Stakeholders means people who are connected with that particular problem. Either they are investing money, or either they are controlling it, or either they are managing it. They people will be connected with this problem. They are called key stakeholders. Okay, so you have to write who are the key stakeholders and who are the team members. And if you want any subject matter expert, what is a subject matter expert? Dr. Siva is a subject matter expert in Lean Six Sigma. So if you are doing any project with Lean Six Sigma, you can call him and ask him for a meeting. He will explain you in detail how the project has to be handled. So he is a subject matter expert. So likewise, you can have a team and proceed with the project. So this is how we used to normally select a team. Project manager, okay, then team members. We will use to have a project team structure like this. So this is a real-time project charter. This is an example. Okay, here you need the business case, then opportunity statement, then goal statement, scope statement, project plan, timeline, and the team members. Okay, a simple report. No need to think about it too much. So this is an actual project report. So it will be look like an Excel sheet. Okay, so the company name will be there, and the plant name, and the date, and the business case, then the problem statement, scope statement, goal statement, then the timeline, and the team. So this is how you develop a project charter. So we start from problem identification, project identification, project selection, then we complete the project charter. So that is how the define phase goes and ends. So in the define phase, we first try to identify the project with the help of 3 methods: voice of customer, voice of business, and cost of poor quality. Then we use a Pareto chart to identify the problem, which is giving you 80% issues. Then that project problem is selected for doing project. Once you select the project, you develop a project charter. See, this project charter must be approved by the top management. At the bottom, you can see approved by project sponsor. Then only you will be able to proceed to the next stage. Okay, they must sign it. Without the signature, it is a invalid document. So you develop a project charter, you get the approval, and you move to the next stage measure. So any doubts, gentlemen? Any questions? Yes, any questions? Because we have taken 5 more minutes. Is there any questions from your side? Joel, anybody else? I think we have.
No, sir.
No.
No, sir.
Okay. If you have no questions, if you don't have any doubts, you can post no. No doubt means no. Okay. Okay, I'm getting a lot of no's. If you have any questions also, you can post it. You will be happy to answer. I'm happy to answer. Okay, thank you. Thank you all. Okay, now we move to Dr. Siva. Yes, Dr. Siva? Priya, madam, are you on the line? Yes, Priya, madam.
Yes, Ravi sir, Mudstingla.
Yes, finished.
Okay, okay. So, just a second, sir.
No issues. So, guys, I believe you would have understand things clearly, right? So, where will you start a project? How will you identify project? Joel. Yes, Joel, are you there? Joel has gone for a sleep.
No, sir. No, sir. I'm available only, sir.
Okay, okay.
Just-
How will you identify project, Joel?
Sir, by the project charter, sir.
Oh, man. I said you 3 methods are available, right?
Voice of customer, voice of business, cost of work
Sir,
quality.
VOC.
Yeah. Very good. Project charter is, creating a plan of execution for your project. Project charter is a document using which you get, approval from the company. Because without approval, you can't actually, run projects in the company. Okay, I hope all of you have had some good session so far with Dr. Ravi. And if there are any questions any of you have with respect to the defined phase, I hope you have gained clarity on voice of customer analysis, voice of business analysis, cost of poor quality analysis, and then what is proactive approach and reactive approach, right? You can always prevent failures by having a proactive approach. You can always resolve failure using a reactive approach, right? I hope that was also discussed with you. CTQ tree is another tool you might have learned, and the Pareto diagram is another tool. Pareto is a prioritization tool, isn't it? And there are so many problems that are going on in the company, going on in the department. You can immediately collect data, plot Pareto, and Pareto can throw light on the most frequent problem. And if the most frequent ones are also the most important ones, then that must be given priority, and then that should be executed as the first project. And similarly, you could have discussed about the project charter. Project charter generally will have 6 elements: business case, problem statement, goal statement, scope statement, team members, and timeline. And then the project charter will be signed by the process owner, project leader, finance controller, and then project sponsor. When all these people sign, then your project is live. All right. So this is what, in essence, Dr. Ravi has covered for all of you. And do you want to ask any question to Dr. Ravi, or I can also answer your question? If there is any such question, please ask your question. Otherwise, we can break for the lunch. And all of you can prefer to come on video. Always, during interactions, be on video. Very good. No questions. I could see, Kumar, Yuvraj typing and few others also. If there are no questions, can any one of you speak for 1 or 2 minutes so that we get an idea of how we have been doing? Are we doing really, in a way that all of you can appreciate? Or are you facing any challenges with us? Please do share some inputs. We are okay with it, right? Okay. So no suggestions, no feedback, no questions. But this is not good on your part, all of you. There are hundreds of people attending the program. If there are not even a single question, there is not even a single opinion, then this is a something seriously wrong.
So the feedback, can I give you feedback?
Yeah, please. That's what I'm asking. Yeah. Yes, Joel.
Yes, sir. Sir, the program was so useful, sir. It was new and strategic.
Very good. Great. See, participants, when you are talking, you can talk in your mother tongue. We are okay with it, right? It is our headache to understand what are you talking. You can use English, you can use Tamil, or you can speak in Hindi. Anybody would like to speak? Come on.
Sir, I had a doubt, sir.
Yes, please. Yes.
Sir, you said there was a online exam according to this.
Yes.
How can we get the material, sir?
Yeah, the course material will be emailed to all of you. It is already sent. You can check your email inbox. And then next week will be the exam. Moreover, you have the complete recording of the session, right? You can watch the session through the YouTube channel. The channel link is shared. Another option also we are giving. You can download a mobile app, Six Sigma with the GSK. That link will also be posted in the WhatsApp. When you download, every next day, you will see the video in the app also. So whichever is convenient for you, you can use, right? So exam will be next week. No worries.
Okay, sir. Thank you, sir.
Yeah. Okay, then. Thank you all of you for your wonderful participation. We thoroughly enjoyed, your participation in the program. So thank you, Dr. Ravi Kumar, for the wonderful session. Thank you all. And those of you who are staying in, watching us through the YouTube channel, thank you. Thank you for your watching, and bye-bye. Have a good day. All the very best. And we'll be meeting you again tomorrow morning again. I'll continue with the session. Thank you. Bye.
Thank you. Thank you.